A confirmation about the audio, please, guys. The audio is clear and available. Kindly confirm. Thank you. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of oceanography, where today we shall be initiating the discussion about ocean currents. So, yesterday, basically, we took a look at few of the features of ocean bottom relief, and then we looked into the physical properties exhibited by water, where we try to understand how is it that the temperature ends up changing from one particular region across the planet to the other part of the planet. And there we saw that the factors such as latitudes, the factors such as the prevailing winds, the existing ocean currents, etc., they end up influencing the temperature of a region. Now, we also looked at the fact that when we talk about temperature, as we go into the depth, the temperature tends to gain a consistency of around 3 to 4 degrees Celsius, the reasons for which we have also elaborated. Now, that means that you will have a zone of transition at around the depth of few hundred meters where suddenly the temperature would change as compared to the surface, and that is what was referred to as the thermocline. Then, similarly, in the case of salinity, not only did we understand the factors that end up influencing salinity and variation of salinity from one area to another, we also tried to understand that how at the bottom, as the salinity is almost consistent, you have a zone of transition in the case of salinity as well, where whatever the surface variation of salinity is, it tries to reach that consistency which is observed at the bottom around 35 parts per thousand. So that zone of transition, again at a depth of few hundred meters from the sea level, that is what was referred to as halocline. So we have taken a look at the thermocline, halocline factors, and then we try to understand what is the thermohaline circulation. And there we basically saw that density is something which is determined by both salinity as well as temperature factors. If the temperature is high, that is, if a water is warm, density will be low. If the water is cold, density will be high. Again, if the salinity is high, density will be high. If the salinity is low, density will be low. This determines the weight and also the sinking and the rising of the water that we experience. And due to this difference, and there we also saw, by the way, that if you have the factor of density and temperature, both of them, if both of them are responsible and are at play together, then always temperature will be the determining factor. Temperature will end up determining that what will be the density of it all. Now, then we looked at thermohaline circulation. What do we understand by thermohaline circulation? That is something that we saw in detail. That you have a kind of a circulation from lower latitude to higher latitude and back to the lower latitude. And that circulation is initiated due to difference in weight of water and how the density changes as water moves from low to high latitude. Then we looked at what do we understand by waves, swash, and backwash, and then the factors influencing the tidal movements. There we saw the tidal movements are initiated or influenced by the gravitational pull by the sun and the moon, and also by the centrifugal force which is experienced as the planet revolves around the sun. So these are the factors which we looked at. So today we shall initiate the discussion from ocean currents. We shall be familiarizing ourselves with the different types of ocean currents which are in existence across the oceans of the world. First of all, we shall be analyzing the Atlantic Ocean, then we shall be moving on into Pacific, and then the Indian Ocean. Now, here the concept will largely remain the same through and through. When you talk about Atlantic, Pacific, or Indian Ocean, the concept or the basic principle driving those currents are going to be very similar. So rather than fixating on the individual names right now, as of now, rather than getting fixated on these individual names and getting too much bothered by any of the ocean, I would urge you to look at the larger pattern, that how the ocean currents they circulate. Once you understand the larger pattern, you'll be able to fit that template in the other ocean as well, and that will lead to a better understanding. So, after this ocean current, we shall be taking a look at the global conveyor belt, Atlantic meridional overturning circulation. That is a part which is very much important and in discussion in current affairs. Then we shall be taking up the portion of corals, coral reefs, before entering into Indian geography. So, here, when we talk about ocean currents, what do we understand by ocean currents? So, ocean currents, on the face of it, the oceans, they appear to be absolutely calm and featureless. Oceans, they do not appear to indicate any kind of movement in a fixed direction. But that is by simple visual appearance. In fact, the reality is something which is quite different. The reality is that across these oceans, you have a significant movement of water in a fixed direction, where a substantial chunk of water is transferred, a volume of water is transferred from point A to point B in a regular direction. There are ocean currents in the world which end up transferring millions of gallons of water every hour as they move. And these ocean currents, they are very large phenomena. This is not something which happens on a smaller scale. They are, first of all, very important in terms of distribution of heat from the lower latitude to the higher latitude, and also dispersion of colder conditions from higher latitudes to lower latitudes. So that is why they are important. They are also relevant for distribution of nourishments and nutrients. The many of the oceanic species and organisms, they are heavily dependent on the availability of these nutrients as provided by these ocean currents. So these ocean currents are going to be very, very instrumental. Now, the knowledge about these ocean currents, again, it is not something which is very new. The knowledge about the ocean currents has been in existence for hundreds of years now. It was during the Middle Ages when you had the Portuguese explorers and travelers and the sailors who would travel across the Atlantic in order to explore the regions of North and South America. Now, they came across these ocean currents quite significantly. And they came across these currents which would help their ships navigate from one region to another quite efficiently well. And that is when people started observing more and more ocean currents, documenting more and more of them, so that the navigation could be aided. So, here what we will study is, what is this ocean current? What are the factors which end up influencing the ocean current? And then the types or the classification of ocean current. Now, here, when we talk about the ocean currents here, first of all, they are like a flow of river in the oceans, right? They are like river flow in the oceans. What that does that river flow indicate? Movement in a definite set direction. That is what the river flow indicates. It has the movement in a definite set direction. Okay. Now, that means regular volume of water in a definite path and direction as it moves. That is an ocean current. Now, this is initiated or this is influenced by multiple factors at a go. So, you have the primary forces which initiate the movement of water, and you also have the secondary forces that influences the currents to flow from one region to another. Okay, so you have both of them, primary as well as secondary forces. This year in 2022 mains, UPSC had asked a direct question about this, as direct as it can be, that describe the forces or discuss the forces which influence the ocean currents. And as we will analyze later on, UPSC has basically repeated this question twice or thrice in the mains exam. In the past 10, 12 years, UPSC has repeated this question around twice or thrice. Okay. So, and by the way, another thing I would like to tell you, that please understand, many of us, we have a knack of preparing for those particular topics which are very, very difficult, which particularly, let's say, they are out of the world, out of the syllabus, out of the topics, out of the books. It is not in those topics that you will lose marks, because nobody will be able to give answer for them. But when you have direct topics asked, direct questions asked from the basic portion, that is where you lose the game, because that is where, when the rest of the field does their work in a significant proficient manner and you perform below average, that becomes a large difference creator. So always be on a lookout for those traditional areas from where UPSC does ask question. Ensure that you don't commit mistakes in those. So here, when we talk about these forces, let us talk about them one by one. So the first forces, or the first influence, is heating by the solar energy. Now the solar insolation which occurs or which is received, that solar insolation significantly reduces or significantly heats up the region around the lower latitudes. Okay, the region around the lower latitudes is significantly heated up. Now, as a consequence of that, those lower latitudes, there, the water, because it is heated up, gains a kind of a height advantage. After getting heated up, it gains a kind of a height advantage. And that means what? There's a height gradient between the lower latitude and the higher latitude. So the natural tendency of the water will be to flow from lower to higher latitude, right? So this heating, that provides in higher or a kind of a height advantage at the lower latitude, right? And this gradient causes the water, initiates the water to flow from one extent to another. But that flow, where will it flow? In which direction will it flow? Will it start flowing randomly all across the ocean? No. The flow is given a direction by the winds, the existing winds that you have. So the winds, here by winds we refer to permanent winds. Permanent winds. The trade winds, the westerlies, the polar easterlies. Now these permanent winds, basically, they will provide directionality. And even if there is a slight expansion in terms of water, these permanent winds will initiate the kind of a motion. So what they do is they provide directionality, provide a definite direction for water to flow. For example, think about it. Let's suppose we consider the planet. Yeah. Let's suppose. Let's suppose here we have the region of equator. Now, if at lower latitudes, we talk about the lower latitudes, suppose here you will have lot of water, right? Lot of water which is having a kind of a height gradient. But where will it flow directly? So here, what kind of winds will prevail at the region of equator, which is the wind which is in existence? Let me know. Good. So here we will have the trade winds in existence. And these trade winds will be moving in which direction? They will be moving like this. So all that accumulated water which was there, that will be carried off in the east to west direction. Same is the case in the southern hemisphere as well. They will be carried from east to west, isn't it? Because the trade winds, they are also moving from east to west in general. So that is how the water will be carried. Now observe this in the previous image that we studied for. Look at the factor of the temperature distribution that we talked about. Observe the flow or the water in the equatorial Pacific, in equatorial Atlantic. Observe this particular portion. Now here, just by simple appearance, doesn't it appear that the water is in a state of motion at the region of equatorial Pacific? I hope equatorial Atlantic. I hope you are able to see. Here it is the trade winds which initiate that motion. So that is why the water overall ends up moving like this, spreading eventually like this. I hope we are able to see that. Right. So that is basically how the winds will provide a kind of a directionality. If the water gets, let's say, a kind of a height advantage due to heating, then the winds will direct it. Observe in the case of Pacific also. Here also, you will observe a kind of a streamline like this, and there is an accumulation in the west. So that is also because the trade winds are carrying it like this, isn't it? So that is where the role of the winds, they come into the picture. The winds not only help the water to move, they provide a kind of a directionality associated. That is the role played by the winds in general. Then after that, you also have the influence of Coriolis force. Coriolis force significantly ends up getting created or acts over a particular any object which is moving independently of the surface. So Coriolis force acts upon, let's say, the wind movement, let's say the ocean current movement, and as per the Coriolis force, and due to the Coriolis force rather, any object moving in the northern hemisphere will end up bending to the right. Any object moving in the southern hemisphere will end up bending to the left. Okay, that is the basic that we have seen. Now here again, how does that come into picture when we talk about the planet? Because we know Coriolis force is absent around the region of equator. It is not present at equator. So how does that come into the picture? So suppose here water is present in this region. Water is moving like this. Now due to Coriolis force, water will bend to the right. After moving significantly, it will again bend to the right. Then again it will bend to the right. And then again it will bend to the right. Okay, so that is the case in the northern hemisphere. Whereas in the southern hemisphere, you will observe if the water is moving like this, it will bend to the left. Again, it will bend to the left. Again and again. Right. So that is basically the movement due to the Coriolis force which is present. So that is why in the northern hemisphere, other than the Indian Ocean is an anomaly. Indian Ocean is an exception, and northern Indian Ocean. So other than the northern Indian Ocean, almost all the other parts of the oceans in general, you will experience that in the northern hemisphere, water initiates a circulation in clockwise direction, and in the southern hemisphere, it initiates a circulation in the anti-clockwise direction. Okay. Now, by the way, Indian Ocean, as I told you, is an exception. Northern Indian Ocean is an exception. Why is that the case? What is that exception? We'll come to it. But before that, I wanted to ask one thing, and I get surprised by the answers many of the times. That is why. How many oceans are there in the world? Are we aware of that? we are talking about oceanography in detail. Hmm. That is why I asked this question. Okay. I should have launched a poll in that case. I think I see the answers ranging from 4, 5, 6, 7. Find out this basic fact you should be aware of, right? It is a high time that you should be aware of this basic fact, that how many oceans are there in the world. Okay? So find it out, and for your own good, you should find it out. If I tell it right to you right now, I don't think it is going to help. So, yeah. Okay. All of you, you are very confident about seven. Which are the seven oceans? Anybody who can list the seven oceans? All those who are saying seven repeatedly, can you tell me about the seven oceans? Which are the seven oceans? Maybe I will also get enlightened by that. Okay, North Pacific and South Pacific, you are considering different. Hmm. Okay, there are only four oceans. Okay. There are in total five oceans which are present. Just find out the name of those five, and that should be sufficient for you. So that is something that I leave it out for you. Now, whether you decide that it is 5, 4, 7, etc., I'll tell you there are only five. Now, rest is up to you. And don't divide it North Pacific, South Pacific, North Atlantic, South Atlantic, North Indian Ocean, South Indian Ocean. If you do like that, then you will end up creating endless amount of oceans out there. Patel, we have taken that issue up. We are looking into it. Let's see uh, how soon it gets resolved. Okay. So basically, we have five different oceans which are present. Okay. So, five different oceans. You have which of those five different oceans? You have basically Pacific, Atlantic, Indian, Arctic, and Southern. These are the basic larger oceans that we have. Arabian Sea is never going to be an ocean. Okay, these are the five oceans that we have. Now, after this, coming back to the topic, when we talk about the Northern Indian Ocean behaves like an exception, and it does not follow the norms of regular ocean current that we observe. And that is because of the shape of the Northern Indian Ocean. If you consider the Pacific Ocean, if you consider the Atlantic Ocean, they are open from the northern extent, right? Pacific and Atlantic Ocean, they extend to higher latitudes both in the northern hemisphere as well as in the southern hemisphere. But in the case of Indian Ocean, you will find that the northern latitudes, the extent is not there up till that point. The ocean is closed by landmass in the north. So that is why, in the case of the Indian Ocean, the influence of the winds is very, very predominant. We'll take a look at it as we come to that. So, here, then we have another factor which ends up influencing these ocean currents, and that is the shape of the coastline. Shape of the coastline is not a major factor, but nonetheless, it provides directionality to the flow. Okay, it does provide a kind of a directionality to the flow. How? So observe, I'll again take you back to the same image. So observe here, as the water is moving, the shape of the coastline has influenced the movement of the water here. Do you observe this? So as the water is being pushed by the trade winds, the shape of the coastline has influenced the motion. Right? I hope you are able to look at this image. So that is how shape of the coastline significantly ends up influencing the movement of these ocean currents. Okay. Now, even for example, when we talk about the other portions, for example, when we talk about ocean currents in the Atlantic region, you'll find that as soon as they come across the group of islands, that is the Caribbean islands, they will immediately end up bifurcating, right? And depending upon the shape here of Gulf of Mexico, observe that the ocean currents, their shape also changes, their direction also changes. And same is the case with the direction or the shape provided by the region of North America. So shape of the coastline, very essential for the ocean currents in terms of providing directionality. Then the other minor factor is the bottom relief. Bottom relief. So, in the case of bottom relief, how does it influence the ocean current? So, here, when we are talking about bottom relief, we are talking about relief features such as mid oceanic ridges. Oceanic ridges. So, for example, if let's suppose here, let's suppose you have water in the ocean or the sea. And let's suppose here you have the kind of a mid oceanic ridge which is present. Right. Now, if bulk of ocean water, let me represent it by a different color so that it is easier to visualize. So, here let's suppose you have the ocean. Now, the bulk of water as it ends up moving, in this case, they will get influenced by this particular mid-oceanic ridge. And that is when, after they get influenced, the particular ocean currents, they end up moving, they get divided, they get trifurcated, bifurcated, and so on. For example, if you recall, in the portion of geomorphology, we had studied about the presence of mid-oceanic ridges in the region of Atlantic. We had talked about the mid-Atlantic ridge, if you recall. Now that mid-Atlantic ridge extends all the way from here furthermore and covers the entirety of the portion of the Atlantic. Isn't it? It spreads for and extends for thousands of kilometers out there. Now, here, when we talk about this mid-Atlantic ridge, it has got multiple small subdivisions and regional names which is provided to it. So, for example, in this particular area of northern Atlantic, you have the presence of a ridge feature, underwater ridge feature. And that ridge is what is also referred to as the Wyville-Thomson Ridge. Wyville-Thomson Ridge. Now, this Wyville-Thomson Ridge, that provides a kind of an obstruction to the movement of the ocean current, due to which the ocean current simply disintegrates or trifurcates and moves into the three different portions. So this offers resistance to the North Atlantic Drift in particular. That current's name is North Atlantic Drift. Okay, and helps to divide the currents into various branches. Okay, due to which the currents, they get divided into various branches. And these ridges, please understand, these ridges are not a kind of a minor portion present on the ocean floor. These are very large features that we are talking about. These ridges in the geographical community, in many of the areas, they are also referred to as the one of the longest continuous mountain range which is present on the planet. Because think about it, the Himalayas, what is the extent? The Himalayas, they extend for almost around 2,500 kilometers, right? When you think about the Andes, they have an extent of close to around 3,000, 4,000 kilometers. But when you think about the aspect of mid-oceanic ridges, can you think about what is the distance that they cover? What is the distance that these mid-oceanic ridges, they end up covering? It is close to around 55,000 to 60,000 kilometers. That is their expanse. That is their extension across the entirety of the planet. Okay, so that is why these are very large features out there, very major features which are out there. And that is why they will always end up influencing, not in all the places. In many of the places, the height of the mid-oceanic ridges is very low and they are hugging the ocean bottom. But in certain areas, they are closer to the surface, and that is where they will influence the ocean currents. Not in all areas, only in certain areas, they will influence the ocean currents. Okay? Now, here after this, we have the various different characteristics of the ocean current. So when we talk about the characteristics, okay, I'll change the color here. Don't worry about it. This is where you have the, I will use a different color, let's suppose. You have the mid-oceanic ridge here. Okay, I hope it is clear now. Now, after that, we come to the characteristics of the currents. So basically, these currents, their speed is going to be very different when they are moving through the surface. Their speed is going to be significantly different when they are moving at a depth. Okay, why? Because these currents, they are influenced by the surface conditions. What are the surface conditions? The surface conditions, for example, the wind pattern, the wind movement, the heating by the sun, etc. So that is where you will find the surface conditions to be very predominant. And that is where the influence on the surface will be significant. Okay. So here, let's say the wind is moving with a very significant velocity. Now, it will be able to drag the top portion of the water with a significant velocity. That will in turn drag the subsurface, that will drag the lower portion, and so on and so forth. Eventually, the speed reduces. Right? So that is the role played here. The role played by the surface factors. Think about it. Solar insolation, wind, all of these, will they end up influencing water at the bottom? Obviously not. They will end up influencing water at the surface. So what you see is that basically here the speed at the surface is close to over 5 knots, whereas the speed at the depth is close to around 0.5 knot. What is a knot? Are we aware of the term knot? So it is basically a unit of speed, which is used to measure the speed in terms of, it is basically representing 1 nautical mile per hour. So it ends up coming to be around 1.8 kilometer, 1.85 kilometer per hour. Okay, so that is the speed. So here of 1 knot. So 5 knots basically ends up meaning around 9 kilometer per hour, 9 to 10 kilometer per hour. So that is the characteristic of the speed. It will be fastest on the surface. The surface will be fastest. Okay, is fastest. It decreases as you go to the depth before eventually diminishing. Then here, when we talk about the types of ocean current, so based on the depth, you have the classification as surface currents and deep water currents. Surface currents to be found on the surface, and deep water currents overall at a particular deeper portion. So surface currents, they will represent only 10% of all the water. That is only up till a depth of around 400 meters, not beyond that. So that is where the surface currents, they will indicate the presence only in the upper portion. Deeper waters, there you have thermohaline circulation and other factors at play. So that is where you will find that the deep water currents, they move around the ocean basin due to variation in density and gravity. Okay, Lakshmi, difference between tides and currents. Tides basically, okay, that means either tides are absolutely not clear, or that means either you have no clue about what is going on in the ocean currents. Any of those factors will be at play when we are getting confused in this. Tides is basically the vertical rise and fall of water. When you have a high tide, water rises up. When you have a low tide, water level falls down. Current is basically the movement of water from one region to another. As you have waters moving from lower latitudes to higher latitudes and vice versa, it moves across a definite fixed pattern and direction. That is the ocean current. Okay, which of these portions is absolutely not clear, Lakshmi? Kindly let me know. Because confusion between tides and currents, that is absolutely not warranted for. Insolation in equatorial regions, insolation takes place equally. Then temperature in equatorial regions also same. No, why will the temperature be same in all the equatorial areas? First of all, the flow does not happen because of that, Mohammed. Flow happens because of a different reason, but the basic concept that you have put forward, that has got a flaw in it. You don't have the condition that across the same latitude, if the insolation is similar, the temperature would be similar. If that would have been the case, then in the entire Walker circulation would not have been possible at all, right? It would not have been possible. Gravity also ends up influencing ocean current, not significantly. Thermohaline circulation, there the role comes significantly. Gravity is many of the times included as a portion, as one of those factors which will influence the ocean current. In, for example, NCRTs, you will find that. So basically, the role of the gravity is restricted to the fact that the water, when it gains a kind of a height advantage, it is pulled to the region where, or its natural flow is to the region where the height is less. So that is why there is a general movement of water from lower latitude to higher latitude. That is basically the aspect. And I don't know what will it take. Do you guys want me to write a letter about it so that you don't paste the same question again and again? What will it take for you guys to not paste the same question again and again? What do you want? Please let me know. I'm ready to do that. Okay, but please never do this thing. The same question I see pasted 3 to 4 times, I'm never going to respond to that question ever again. Okay, let me make myself very clear. Vanshika, Wyville Thompson Ridge main characteristic is Wyville Thompson Ridge is a part of the mid-Atlantic ridge, and that Wyville Thompson Ridge offers a kind of a resistance to the movement of the ocean current, due to which the ocean current ends up getting divided. The ocean current ends up getting bifurcated or trifurcated. That is basically the role played by Wyville Thompson. So the mid-oceanic ridges will not always end up forming a kind of an obstruction. In certain areas, they are closer to water, and that is when they will have an influence. Does not mean that anywhere where there is a mid-oceanic ridge, there will be an influence on ocean current. No, only where they come particularly closer to the surface of water. Characteristic of current. What do you want to understand on the characteristic of current? In what aspect? Ocean current basically is the one which moves from one region to another in a definite direction. It has got a definite speed. It is influenced by various different factors, and then its classification is there. We are studying the classification. Then we will study the types of ocean currents that are there. So wait for some time. After that, automatically you will understand what is the characteristic. Waves are found near the shore. Why? No, waves are found everywhere. Near the shore, the influence of the winds is much greater. And because the depth starts reducing, that is why the waves, they start accumulating. Remember, I told you yesterday that closer to the shoreline, as the depth decreases, the waves, the water starts accumulating, and there is a swash, and then there is a backwash, right? That is the factor that you see in the case of waves. So always understand that waves are in existence even in the deepest of the waters. Deepest of the waters will have very large waves also. Will current only found at ridges? Why? Why do you have this doubt that will current be only found at ridges? Can we simply can we say simply current is a movement of water in a definite path? Absolutely yes. Can we say ba- coast, coastline act as a barrier to oceanic flow, so oceanic current? They in a way shape the direction. They provide the direction. How is Coriolis force impacting the oceans? Pragya, Coriolis force does not impact the oceans per se. The Coriolis force provides directionality to the ocean current. If the water is in motion, it is independent of the surface. So that is when you'll find that the Coriolis force ends up bending the movement in the rightward in northern hemisphere and leftward in the southern hemisphere. Okay. 1 knot is equal to 1.85 kilometer per hour. Okay. And so Vivek, your question is that, and that will current be only found at ridges? Absolutely not. No, that is as wrong as you can get about it. There is, I don't think you can commit a more major mistake. That what are ridges? Do we have an idea about what do we understand by ridges? Let me know, Vivek. Write an answer about it and let me know, what do you understand by ridges? And that means you have no clue about either the ocean current or the mid-oceanic ridge or any oceanic ridge. What is an oceanic ridge? Oceanic ridge is the region of active volcanism or a kind of a region of divergence, present or past, which is to be found at the ocean bottom. And till now, whatever we have seen about the ocean current, does any of the feature tell you that it will be found at the ocean bottom? Think about it. Equator temperature is high, and high evaporation is as well high precipitation. No, Shalu, in that case, the evaporation is not as high as compared to the precipitation that you receive at the equatorial areas. So that is why, because the precipitation is high, it occurs on a daily basis. That is why you will find the equatorial areas to be less saline. Ashwant, land breeze and sea breeze, they are not considered onshore and offshore in general because they are over a short distance. You have the permanent wind systems, which are considered onshore and offshore. Okay. So I think majority of the questions have been answered. Two types of current based on depth. Two types of current based on depth. I'll tell you, you have the surface current and the deep water current. So basically, depending upon where the current is in motion, you have the surface current, or the top portion of the water which is moving, that is influenced, that is referred to as a surface current. And in the bottom portion, you have the deep water current. So the deep water current, they are mostly influenced by the factor of temperature and salinity. So mostly the deep water currents that you will come across, they are influenced by thermohaline circulation. Influenced by thermohaline circulation. Okay, that is difference in temperature and salinity level, and that is something that you experience in the case of deep water currents. Now, based on temperature, the ocean currents, they are divided, they are classified into cold currents, and they are also classified into warm currents. That is the classification based on temperature. Now, here, when we say cold currents and when we say warm currents, we don't have an absolute temperature that, okay, if the currents or the ocean water's temperature is less than, let's say, 20 degrees Celsius, only then a cold current, otherwise a warm current. No, we don't have any absolute ceiling like that. So when we talk about cold current or warm current, this classification is done based upon the comparative temperature of the surrounding region, that how the temperature varies in the surrounding waters. So for example, first of all, let me write it down. So, ocean currents are classified based upon the comparative temperature with surrounding waters. So, if the current is colder than the surrounding water temperature, right? It is cold current. And vice versa. Okay. So that is basically how you cannot simply designate that this will be a cold current, this will be a warm current. You will basically observe that if let's say the ocean current has got a temperature of 18 degrees Celsius, but as the surrounding water temperature is 10 degrees Celsius, it will always be considered as a warmer current, right? So the same ocean current can be, in a way, cold or warm current depending upon where it is going. I will give you another example of this. So for example, suppose you consider this to be the ocean current moving here. Let's suppose the temperature of this ocean current is, let's suppose, 20 degrees Celsius, right? Now here, if it moves to higher latitudes where the surrounding water temperature maybe is 15 degrees Celsius. So if it moves to higher latitudes, then it will be regarded as a warm current, right? And if the same ocean current moves towards the lower latitudes here, then if the lower latitude, the temperature, let's say on an average is 24 degrees Celsius, and here you have the 20 degrees Celsius water which is coming, this will be then regarded as cold current. So it always depends upon what is the surrounding temperature. In general, the general thumb rule that you can always follow is that whenever we have water being brought from higher latitude to lower latitude, it will be colder. Whenever you have water being brought from lower latitude to higher latitude, it will be warmer. So they bring cold currents, bring water from higher to lower latitudes. Okay? That is where they will bring the water from, and that is where they will carry the water to. Now, after this, you'll find that they are mostly found to the western side. The western side of the continent. Better not rub it. Use it for reference and for your revision also. So, mostly you will find that in the mid latitudes, you have the presence of the cold currents in the western part of the continents. Okay? West coast of the continents. And why is that? Because in these areas, you will observe, in the case, let's say, when we talk about the western part of the continents, if this is, let's say, the continents, any continent that you consider, let's suppose, any continent that you consider, the western part will experience significant amount of trade winds. And these trade winds, what they will lead to at the coastline? These trade winds, they will cause upwelling across the coastline. And when they end up causing upwelling or creating upwelling conditions, that will basically bring colder waters to the surface. So mostly that is one of the reasons, but there are a lot of other reasons for the existence of the cold currents, and it is generally the water which is brought from higher to lower latitude that is regarded as a cold current. Now, warm current, when we talk about, so they bring warmer waters into the colder areas, as simple as that. Or we can say carry water from lower latitude to a higher latitude. They carry water from a lower latitude to a higher latitude in general. Okay? Now, that is the case of warm currents in general. Now, after that, here you will find that mostly the warm currents are to be found on the eastern edge of the continents in lower and middle latitudes, on the eastern side of the continents. And why is that the case? That is because if you consider the eastern part of any particular continent, let's suppose, here you have, let's suppose, a continent. Now, on the eastern part, due to the trade winds, what do you experience? You will experience downwelling, isn't it? Downwelling, as is caused, that will raise the sea surface temperature. So here, downwelling raises the sea surface temperature. Okay, and that is why mostly you will find warm currents in general prevailing in that area. Now, let us take a look at the ocean currents in existence in different oceans, and let us try to find out the overall trend that you observe. Okay, so when we talk about the various oceans, we start with the Atlantic Ocean. Generally, questions are asked about the Atlantic because this is where In sometimes it has also been asked from the portion of Indian Ocean, but Atlantic in a way has got all the characteristics to represent the ocean current based on all the forces that we have studied. Now right now what I want you to do is please understand that all these ocean currents, their details would be given to you in the additional reading materials. It would be available with you. Right now what I want you to do is understand and observe the phenomena, observe the mechanism. Once you understand the mechanism, it can be implemented in the Pacific, it can be implemented in the Indian Ocean also. So when I talk about the mechanism, please pay attention. You want to note down something very quickly, you can do, but please ensure that you don't miss out the exact pattern of the entire ocean current circulation. Now, when we talk about this particular region of Atlantic Ocean, right here, when we talk about the Atlantic Ocean, let us first of all consider the North Atlantic, and then we'll come to the southern part of Atlantic. Now, when I am saying North Atlantic, kindly pay attention to what we are talking about here. So initially, what have we seen? We have seen that around the region of equator, water starts piling up, isn't it? Water starts to pile up, and due to intense amount of heating, the volume tends to increase. There is a kind of a height gradient which is achieved. Now when you achieve that height gradient, water is ready to flow. All it needs is a direction. So where do we get that direction from? By the winds. So around the region of equator, you will have the movement of which winds? The trade winds. Trade winds in general will be able to carry the water from east to west, because the general direction of motion of these trade winds is what? General direction of motion is from east to west. So in general, they would be able to move water from east to west. Now, as they are able to move the water, push the water from east to west here, they will hit the coastline. They will hit the Brazilian and South American coastline in general. Now, some water will start accumulating here due to the push of the water which is carried out by the trade wind. But overall, both in the northern and the southern hemisphere, as these winds are pushing, observe the water is getting pushed by the trade wind from east to west. They are diverted by the shape of the coastline then. They are diverted by the shape of the coastline. Now, in the northern Atlantic Ocean, as we were taking a look into it, here the water has diverted to the north due to the shape of South American continent. Now, as the water has diverted, here it will encounter the Caribbean islands. You have Barbados, Bermuda, Trinidad, Tobago, all of these islands are present. So, around these, the ocean currents will hit them. Now, what do you think will happen? Will the ocean currents start riding over the islands chain? No, they will get divided. They get bifurcated. And that is where one portion moves from the northern part, the Antilles current as it is referred to. Another portion moves to the south of these islands. Now, the one which moves from the south of these Caribbean islands, they will enter the Gulf of Mexico. This is the Gulf of Mexico. They will enter the Gulf of Mexico, and here they will move through here, and they will then find an exit around the region of Florida, the state of Florida. Okay, around the state of Florida, they will find an exit. Now, meanwhile, observe till now. Again, water being carried from the region of equator from east to west, shape of the coastline. Look where the shape of the coastline has led the water to. exiting from the region of Florida. In that small portion, it is referred to as Florida current, right? Now, that Florida current, when it comes out of the Gulf of Mexico, it is then joined by the northern part of this Antilles current, which was moving from the northern side of the Caribbean islands, the region around Bermuda. Now, they will end up joining together. And joining together, think about the features that it will have. The volume of water that will be contained will be enormously high. Secondly, the temperature will also be very high. Why? Because there is intense amount of warmer waters being brought from the region of equatorial area. So the temperature will be high, the volume will be high. This initiates these together. When they come together, that is what will initiate one of the strongest warm currents across the globe, and that is the Gulf Stream. This is one of the strongest and the most powerful, one of the powerful warm currents across the planet. It ends up moving millions of gallons of water every hour from one region to another. Now, here, as the Gulf Stream traverses north, observe that not only the shape of the coastline but also the Coriolis force has got its role in bending the Gulf Stream. Meanwhile, you have water coming from higher latitudes to lower latitudes. Now, here you might have a question that why is it that water will come from higher latitudes to lower latitudes? Because till now we have studied in thermohaline circulation, in ocean currents, that water at lower latitude gains a height, and that is why it flows to higher latitudes. But what is the excuse for the water from higher latitude to come to the lower ones? The reason is very simple. It is basically the portion which has got, let's say, the permanent winds in this region is the easterlies, the polar easterlies. Now they will end up initiating a movement in the water. And after that, the shape of the coastline that you find, that initiates the direction that you have. Okay, so that is why it is the factor of both of these. That is the wind factor, the shape of the coastline. If the shape of the coastline had not been so as it is described, the water would have moved in the direction that the polar easterlies move. So here, that is why water follows or flows from higher to lower ones. Now, after that, here, you would observe that the water will bend slightly to the right. Even the cold current will bend slightly to the right. And why? Because of the Coriolis force. It will bend to the right. Now, here, you will observe that there is a mixing of warm and cold ocean current. Whenever you have mixing of warm and cold ocean current, it forms an ideal fishing ground. Ideal fishing ground. Okay. So here it is very ideal fishing ground in the sense that where colder and warmer waters meet, the basic oxygen supply in the water increases, due to which the phytoplankton population would increase, and that would lead to a significant increase in the population of the fishes as well. So that is why you have wherever you have warm and cold ocean current meeting, that forms a very large and a very ideal fishing ground. Other than that, you will have macroclimatic changes experienced as well. For example, warm ocean current, cold ocean current, as they encounter, means warm air and cold air will meet above them also. So you can have the formation of a kind of a front, or you can also observe the formation of a foggy condition in that area. So both of them can be created, both of them can exist in that region. So that is why in these areas, it is also very, very difficult for navigation, because you will find a lot of fog to be in existence. As warmer air encounters with the colder air, immediately at that zone, a lot of fog will be created. Nonetheless, further initiated and further influenced by the Coriolis factor, Coriolis force, and then after that, aided by the movement of the westerlies. The westerlies are very active in these latitudes. So that is where the water you will observe of the Gulf Stream, that starts moving in the westward, or rather from west to east. Now it is in this region where it is also referred to as the North Atlantic Drift. Now, as it encounters the Weill-Thomson Ridge that we talked about, the mid-oceanic ridge, that is when this gets trifurcated. One part, in fact, there are multiple divisions, but not very much needed for your general studies. For your general studies, these basics are sufficient. So here, you'll find one part goes around the region of the Scandinavian area, and that is what is referred to as the Norwegian current across the region of Norway. Now, this is relevant in order to make the waters or keep the conditions of temperature around the region of Norway and northern part of Europe much more moderate and tolerable. Okay, because you have warmer waters carried by them. That is why the temperature is much more tolerable in general. One part of this current will end up entering through the region of Bay of Biscay here, and then they will exit. And then one part, in fact, one of them even enters the portion of the through the Strait of Gibraltar into the region of Mediterranean Sea. So that is how you have the North Atlantic Drift. Depending upon the various indentions that you have in the coastline, they get divided. You have many different subdivisions, Rennell current, Irminger current, etc., but not required for your general studies. So we will ignore that. Now, this North Atlantic Drift, eventually, as it starts moving from west to east, it will also end up bending to the right due to the Coriolis force. And as it bends to the right, now it is basically carrying warmer of waters from higher latitude to lower latitude. Okay, it is carrying water from higher latitude to lower latitude. So let's suppose the temperature of this North Atlantic Drift, let's suppose, is 18 degrees Celsius. Let's suppose, as an assumption, I'm telling you, the surrounding water temperature is 10 degrees Celsius. So it will be significantly warmer current, isn't it? In fact, the temperature of water in this region can be much lesser than 10 degrees Celsius. It can be, let's say, 5 degrees Celsius. So it is a warm current. But the temperature at the tropics is close to around, let's say, 24 degrees Celsius. Now, in this condition, if an 18 degrees Celsius water comes over, what do you have? You have a cold current. So that gives rise to the cold Canary current, which is in existence. And why the name Canary current? Obviously, because of the Canary Islands, which are situated on the western part of Africa. So that is where you have the Canary current. And it is colder. It recirculates back into the North Equatorial current. Okay, I will repeat the entire process once again. Kindly pay attention, and kindly, all of you who have understood, take this as a point of revision. All those who have not understood, try to concentrate again. So, we start first of all around the equatorial area. Around the equatorial area, due to intense heating, there is a significant amount of expansion in the volume of water. Now, water has expanded around the region of equator. But then, where will it flow? Will it straight away simply start moving across the northern latitudes? Absolutely not. So, water has been given a direction, or is given a direction, by the existence of the winds. Around the region of equator, you have the presence of trade winds. So when you have the presence of trade winds, this what it does, let's suppose these are the trade winds. Now these trade winds, what they will do is they will push the water from east to west. So that water gets pushed from east to west, both in the northern and the southern hemisphere. That is when they will encounter the coastal feature. They will encounter the coastline. As they encounter the coastline, the water will divert. Okay, because of the shape of the coastline. Now, some part of that water which is pushed to the west here, as the water is pushed to the west, some part of that water will start accumulating here around the western Atlantic. Now, planet is consistently rotating from west to east. That provides a kind of an inertia. You have the planet consistently rotating from west to east, isn't it? So that provides the inertia due to which this accumulated water tends to have a kind of a flow back from where it came from. So that is why you will find the presence of a counter equatorial current also in existence. And that is because all that water which has been carried by the trade wind from east to west, that starts accumulating, and then some of that initiates a flow back which results in counter equatorial current. But nonetheless, while we are taking a look at the northern Atlantic, as the water has started moving northwards due to the shape of the coastline, here they encounter the Caribbean islands. And after encountering the Caribbean islands, they get bifurcated. One part moves from the north of it, one part moves to the south of it. So they will get bifurcated here. Here they are referred to as Antilles current. Antilles current. Now, the portion which moves to the south of these islands, they will enter the region of Gulf of Mexico. They will enter into the region of Gulf of Mexico and traverse through the region of Gulf of Mexico. After that, when they come out from the region of Gulf of Mexico, here they come out from the region of Florida. Florida, the southeastern state in United States, and one of the very relevant one in terms of even environment and ecology that you study, you will come across a lot of references about Florida. So Florida, as it comes out from that area, this particular movement of water is referred to as Florida current. Now, Florida current meets with the Antilles current, right? And that basically joins the water for these two. So the temperature increases. Temperature is high anyways because these are carrying warmer waters, and the volume of water also increases to create one of the most stronger, more powerful warm ocean currents, that is the Gulf Stream. And the Gulf Stream is created. That Gulf Stream initiates its motion to the north here. It initiates its motion to the north. Now the westerlies have also come into the picture. And meanwhile, you have a cold current near the region of Labrador Sea in the north. That is the Labrador current. And that Labrador current eventually ends up mixing with the Gulf Stream. Now, that Labrador current brings colder waters from higher latitudes, and it is initiated by the polar easterlies. They are the permanent winds in that region, right? In the higher latitudes, which is a permanent wind. You have the polar easterlies. You don't have trade winds or westerlies in higher latitude. So they will initiate a motion of the water, and then aided by the shape of the coastline, these colder currents will come and meet with the warm Gulf Stream. Wherever you have the meeting of the warm and the cold ocean current, it forms a very ideal fishing ground. It also ends up creating conditions of fog and navigational disasters. Meanwhile, Here, as the cold current meets here, yes, some amount of cooling of water will happen. But by now we are in high latitudes, close to around 60 degrees. And the westerlies, they start carrying the water from west to east. And then we have the North Atlantic drift. And this North Atlantic drift basically divides into 2 to 3 portions, depending upon the shape of the coastline and also the Thompson Ridge, that is the mid Atlantic ridge that passes through. So the North Atlantic drift basically gets trifurcated as a consequence. Now, here, one part will move across the Scandinavian region or the region around Norway, Norwegian current. One part will enter through the region or will circulate through the region of Bay of Biscay here. One part even enters through the region of North Sea. One part goes through the region around Iceland. So you have multiple divisions, but these are not the major ones. The large amount of water keeps on circulating, bending to the right due to the Coriolis force. And now, this is going to bring water from the higher latitudes to lower latitudes, and that forms a cold current, which we refer to as the Canary current. The Canary current provides water or recirculates water back around the equatorial region, and you have a complete circulation, which is achieved. Okay? In the southern Atlantic, a similar feature is observed. Notice here, in the southern Atlantic, as the ocean currents, they are basically moving to the portion of Brazil. Here, they will encounter the coastline, and near the coastline, they will end up getting diverted. They will start bending. And here, they will bend to the left due to the Coriolis force. Here, you have the very warm Brazil current, which is in existence. Now, across the entirety of the planet, particularly aided by the westerlies. In the Southern Ocean is the one which surrounds the region of Antarctica. So in the Southern Ocean, you have a consistent west to east motion, which is also referred to as west wind drift. You'll find this west wind drift to be in existence even in the case of the Pacific, even in the case of the Indian Ocean. So west wind drift is a kind of a circumpolar movement of the air or the ocean current in general, aided by the westerlies. Now, as the warm Brazil current is coming here, some portion of the cold west wind drift will get diverted to the left, and that forms the Falkland current. It is around the Falkland Islands. Remember Falkland Islands? You would have read about it or heard about it, the very famous Falkland War, which was initiated by between Britain and Argentina. That is when Falkland came into significant amount of prominence. So it is around those Falkland Islands that you had the Falkland current, which would bend to the left due to the Coriolis force, and they would end up interacting with the Brazil current. Now, after that, this Brazil current basically intermingles with the cold west wind drift. And meanwhile, the west wind drift, again, you will find it experiences a leftward drift. And this time, it moves across the western coast of Africa. And that is where it is referred to as Beniguela current. Okay, that is where it is known as the Beniguela current. And this Beniguela current again supplies water back to the equatorial current, and you have a complete circulation which is achieved. Okay, is that understood? Good. Any doubts that we have? Akula, do polar easterlies bring Labrador current towards the lower latitudes? They help, yes. Shallow traveling, that will not lose heat. They will lose heat. Here, when you talk about, are you talking about the North Atlantic drift? They will lose some heat, but the surrounding water is much more colder, right? So that is why they are basically warmer. Okay. Sargasso Sea, we have not even talked about right now, Vanshika. Don't worry. We'll come to Sargasso Sea later on. Raghav, pyre is basically a kind of a cremation thing that you do, right? You burn the bodies on the pyre. You basically pile up the bodies and then you burn it. But why would you ask the meaning of pyre? Are you meaning to ask the question of gyre, and you have put the word P instead of G? Is that what it is, Raghav? Because pyre is completely different. It is used for cremation, and gyre is completely different. So, okay. Oh, you meant to ask gyre, is it? So gyre is basically when you have water initiating a kind of a circular motion in general, and that circular motion is aided by the Coriolis force and the wind factor. That initiates a kind of a motion in a round and round manner. That is a gyre. Observe, you have a gyre here, you have a gyre here also. So that is what creates a gyre. Okay. How counter-equatorial current flow from west to east? It is basically the water which starts accumulating in the region here. The water starts accumulating, and understand the planet is consistently moving at a swift speed uh, around from the region of west to east. So that initiates a kind of a motion, that provides a kind of a motion from west to east. Okay. Uh, Why ocean current in the northern hemisphere they move clockwise? Because of the Coriolis force, they will bend to the right, and in the southern hemisphere they will bend to the left. Now, I understand majority of you have the same doubt as of now, as I can see, that do we need to learn these names? So, after repeated amount of revisions, you will be very familiar with these names. Ideally, from an examination perspective, prelims perspective, you should be aware about which current exists in which ocean and whether it is a cold or a warm current. Okay. And this will not happen if you leave it that, okay, this is a complicated thing, I will do it before the exam. No. If you revise it, if you take a blank piece of map or a blank map of the world, and then you start drawing on your own. Start drawing by the basic principle. Wind movement, Coriolis force. Wind movement, Coriolis bending. That's it. So automatically, if you practice this twice or thrice, you will be very proficient in this. Yes, Femina, that is correct. Pavitra, can we refer Bengal's current? Beniguela current. Okay, Beniguela current and Canary current refer as trade currents. No, we cannot. And west wind drift not following the Coriolis force. They will follow the Coriolis force. See, it is here, it is moving and carried by the westerlies. Observe, they are then bending here. Here, if you are talking about why this north, the portion here about North Atlantic drift or the Norwegian current, why it then bends to the leftward, that is what we have talked about. Here you have the Wyville-Thomson ridge, and that simply diverts the water in that direction. Okay. Ocean current, how they move high latitude to lower latitude, they will move, the movement is initiated by the winds will be in existence here also. Now these winds will initiate the movement of the water, but the water will hit the coastline, so the water will then be channelized depending upon the shape of the coastline, and that is how you have the cold currents of the higher latitudes in existence. Beniguela current is created as you have some part of the west wind drift that simply bends to the left. Yes, Nisarga, that is correct. Okay. Why do Beniguela current turns warm when crossing the equatorial area? Beniguela will not cross the equatorial. Okay, you are talking about this. So please don't get confused by this particular imagery that you see. Kindly ignore this. Beniguela current basically supplies water to the south equatorial current. Okay. After do Eastland accompany Green do East Greenland current accompany Labrador current, Priyanka? No. So this East Greenland current also slowly and steadily discharges water and mixes with the North Atlantic drift. Deep ocean currents are found very close to the ocean floor, or in certain cases above that as well. And after the trade winds encounter the coastline, the water flows from east direction. It's happened due to Coriolis force. If after the trade winds encounter the coastline, the water flows from east direction, right? It's happened. See here, please understand, the trade winds, they will push the water from east to west. And as they face the obstruction of the coastline, that is when they will divert. Okay. So that is the case about the Atlantic Ocean. Now we will come over to the portion of the Pacific Ocean where you will observe the same feature to be in existence. Okay, so that is where you will observe the same feature to be in existence even in the case of Pacific. Now, Falkland current, those of you who are concerned about Falkland current, please understand it is also a part of the west wind drift circulation across the oceans of the Southern Ocean. And there, some part of the water will bend to the left owing to the Coriolis force, and that is when they will meet with the warm Brazil current. Okay, so that is basically about the Atlantic. Now we come to the Pacific. Here, the same concepts will apply in this region also. Ditto same concepts will apply here. Pacific is the largest ocean across the globe. So Pacific will have its own kind of nuances and tricks and trade that Pacific will apply here. But other than that, overall, you will observe a very same kind of a logic and phenomena. Understand why and how. So again here, around the region of equator, there will be significant amount of heating, and that heating will end up expanding, significantly increasing the volume of water. It will gain a kind of a height gradient. And then you have the trade winds which are persistent here. These trade winds which are persistent, they will be carrying the water from east to west. So they will carry the water from east to west. So you will have the north equatorial current, and simultaneously here also you will have the south equatorial current. Just like in the case of the Atlantic, you had the north equatorial and the south equatorial. Now, this north equatorial current, aided by the obstruction in the form of hundreds and thousands of islands of the region of South China Sea and Western Pacific, they are then deviated. And then they start bending to the right due to the Coriolis force. Now the islands around Japan, they will basically divide this current into two parts. The one moving to the east is referred to as the Kuroshio current, and one moving to the west, that is the Tsushima current. Tsushima is not a very large or an influential current. Kuroshio still carries significant amount of volume of water. So Kuroshio is still important, but not the case with Tsushima. Now this Kuroshio current meets with the cold ocean current coming from the northern latitudes. That is the Oyashio. Okay. So here you have the Oyashio, the cold Oyashio current, which is present. Now this Oyashio current meets with the Kuroshio. And here also, you will have very ideal fishing ground which is in existence. Now then, after that, the Kuroshio starts moving eastwards, west to east, aided by the westerlies in general. So here you will observe in the case of the Atlantic, we had the Gulf Stream meeting with the Labrador and then moving in the direction of east. Here you have Kuroshio meeting with Oyashio and then moving in the direction of west to east. Now this is the North Pacific drift, North Pacific current. Now, as it encounters the American coastline, this current will break, this current will bifurcate. It will have a motion in the higher latitudes. Now understand, This current, when it goes to the higher latitudes, it will always be a warm current. Why? Because in the higher latitudes, the temperature will be much lower. Let's assume, okay, the temperature here, let's assume is again around 18 degrees Celsius. Temperature in the higher latitudes around Alaska can very well be around 5 degrees Celsius. So this will be regarded as a warm current. But the same 18 degrees Celsius temperature current, when it comes to the lower latitudes, where the temperature on an average is around 24 to 25 degrees Celsius, it will be regarded as a cold current. And that is why you have the cold California current. Here, you had the cold Canary current, right? In the case of Atlantic, here you have the cold California current, which is in existence. So that is how it then recirculates back to the North Equatorial current. In the Southern Pacific, very similar. Here, again, they will get diverted to the left. You will form the East Australia current that will supply water to the cold west wind drift. This part of west wind drift, some part will basically bend to the left, aided by the Coriolis force and the shape of South American coastline. And that is when you have the cold Peru current, or the Humboldt current as it is known. So that is the circulation that you observe in the Pacific Ocean. Okay. And here, interestingly, some portion also enters into the portion of the Indian Ocean. That is what is referred to as the Lewin current. Lewin current. Okay. So basically, it is some portion of it very slowly enters into the portion of Indian Ocean. So that is basically the condition of the uh, Pacific Ocean and the ocean currents in this existence. These currents, they reinforce Enzo cycles, yes. How counter equatorial current possible? Where would it accumulate? So counter equatorial current is formed when the water carried by the north equatorial and south equatorial currents, when they will pile up around the region of the western part of the ocean, then owing to the rotation of the planet, that tends to flow back, because the rotation of the planet is west to east. So due to that rotation around the equator, you have very feeble wind movement, very slow wind movement around the region of equator. And that is what is also sometimes referred to as equatorial westerlies. Equatorial westerlies. Very slow movement. Very slow movement of air around equator. Aided by the west to east rotation of the planet. Okay, so that is basically how you will observe a kind of a flow back of water, also aided by the west to east rotation of the planet, and that is how you have the generation of counter equatorial current. Why in it gets split into Alaska current and California current? Because it experiences obstruction in the form of the west coast of North America. That is why. Anthony, a gradual fading out. They will never have an abrupt ending. Out in the nature, nothing has got an abruption associated. Why the Alaska current is moving in opposite direction? You mean the leftward direction? Aided by the shape of the coastline, my dear friend. Look at the shape of the coastline. Which counter equatorial current and Beniguela current also mix. So there is also good fishing ground and navigation disasters. No, navigation disasters won't be caused there. Fishing grounds are created, because please understand, by the time that the Beniguela current, and you have this almost a similar scenario in the case of the Peruvian coastline also. Now, if you take a look at it, it will have some impact in the mixing of water. It will increase the phytoplankton population to some extent. But by the time that the Venezuela or the Peru current reaches the region of equator, the temperature is warmed up significantly. You don't have that great a temperature gradient. But so if you don't have that big a temperature gradient, fog formation unusually won't be observed. But yes, it can aid in the fishing portion. Okay. Counter equatorial current, please understand, when you have the water being carried by the north equatorial current and the south equatorial current, what do you think will happen? Imagine for a moment, what do you think will happen? Very neatly, like a class 1 student or a class 1 candidate, will the water immediately start following the diversion path that I have to follow this line, I will go there? No, some water will accumulate, and that water which has accumulated will always have a flow back. Accumulated water will have a kind of a flow back, and that generates the counter equatorial current. Okay, so now we take a break, and then after the break we talk about the portion of Indian Ocean. Okay, so here we take a break. I give you a 15 minutes break for today. Come back after 15 minutes. Okay. Yatendra, the Canary current is formed actually much later as compared to where the ridge is experienced. Okay. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. So I hope till now, see, there will be a scenario where some of the portions of the currents might not be easily, in a way, recallable, right? Many of the new names you are coming across for the first time in your lives. So it is absolutely okay to feel a little amount of hesitancy in order to, when you approach this ocean current, that what is this Beniguela current, what is this Kuroshio, Oyashio, Labrador. You would have come across these names for the first time in your life, so many of you. So absolutely okay to have a little amount of hesitation, but as long as you are able to catch the larger picture, that why is it that the ocean waters will move, and in what pattern will they indicate the movement, if that is there, more than sufficient. Slowly and steadily, the more revision that you carry out, the more repetitions that you carry out, these will be or these will turn out to be one of the low hanging fruits for the examination. Okay, if you understand the logic here, just observe what is being done in the class and the PPTs, more than sufficient. Okay. um, why California current is cold? Because it brings water from the higher latitude to the lower latitude. That is why it is cold. Same is the case with the Canary current. Canary current also brings water from the higher to the lower latitude. Hence, it is cold. And Shalu, you had a question that it means warm current change its name to cold current when moving from higher to lower latitude, and cold current originate from, yes, that is correct. And Vivek, can East Australia current provide good fishing ground? Not so much, no. Yes, Anjali, that is correct. Uh, okay. So I hope we can progress further. We can proceed further. As per your statement, Ashish, North Atlantic drift is 20 degrees Celsius, but Canary current is 28 degrees Celsius. No, my dear friend, Canary current can never be 28 degrees Celsius. So, what I was telling you about, please understand, ocean current will never gain a temperature more than 24-25 degrees Celsius. Because above 27 degrees Celsius, the water becomes so warm that it activates a low pressure cell. Understand, here when you talk about the ocean current in this region, if the temperature, I am telling you to assume, if the temperature, let's say, is 18 degrees Celsius in this region, let's suppose the temperature is 18 degrees Celsius. Okay, the surrounding water temperature in these higher latitudes might be around 5-7 degrees Celsius, 10 degrees Celsius. So hence it is a warm current. But this 18 degrees Celsius water, when it comes to the lower latitudes, the temperature will be easily around 24 degrees Celsius, 24, 25. So this 18 degrees Celsius current in the surrounding water, where the surrounding temperature is 24, 25, will always be regarded as a cold current. Okay, right? Is Alaska current an exception from the Coriolis force? No. Alaska current basically is having that kind of a movement aided by the shape of the coastline. Look at the shape of the coastline in that part. That is why the Alaska current has got that kind of a shape. Leuven current basically, Vivek, is where you will observe that in the case of the Leuven current, as the warm waters are being pushed to the Western Pacific, some part of it will pass through the gaps which are present and will enter the Indian Ocean. Tsushima current, Palak, is also being supplied from the lower latitudes. That is why it will be warmer. When water from the lower latitudes will be carried to the higher latitudes, it will always be warmer, isn't it? So that is why. Kartika, while you're teaching, I can understand everything. Reading out in a book feels difficult. So do one thing. First of all, after the session, try to write it in your own words. Get the concepts clear in your own words, and then try to create a kind of mind map on your own, and then take a look at the book. So book should always be taken as a source of revision. Okay. Ashwant, the Pacific Ocean near the Australia is said to be Western Pacific region. Is it because of viewpoint based on 180-degree longitude, even though? No, it is the reference point. For example, what is the direction? Direction is always based on a reference point. So if you consider the entire portion of the Pacific Ocean, this will be the northern Pacific near Alaska. This will be the southern Pacific, western Pacific, and eastern Pacific. Similarly, Atlantic, western Atlantic, eastern Atlantic, northern Atlantic, southern Atlantic. Okay. Is there circulation in southern hemisphere current? Yes, there's a circulation in southern hemisphere current, Vivek. So in southern hemisphere, you have almost a similar kind of a circulation based on the similar factors. Now we come over to the exception case, and that is the case of Indian Ocean. Now here, understand that Indian Ocean is different as compared to the other oceans. Why? Not because good people live in India and hence Indian Ocean is much more virtuous. No. Here, if you take a look at the Indian Ocean and the profile of the Indian Ocean, you will observe that from the northern extent, it is closed. It is closed around the tropics. Whereas in the case of the Pacific, in the case of the Atlantic, observe it is open in the north and the south. But in the case of the northern Indian Ocean, it is closed from top. So, as the northern portion of the Indian Ocean is closed by the landmass, here you will observe a greater influence of the wind action. The wind, along with the shape of the coastline, they become dominating factors in influencing the direction of the ocean current. Okay, so here, as northern Indian Ocean is surrounded by landmass or is closed by landmass, influence of winds and shape of coastline become much more prominent. Okay, that is the factor that you come across. Now, how is it that the shape of or the coastline and the wind factor will be influential here? That is because, as compared to the other two oceans, this is the only ocean in the northern part, at least. We are talking about the northern Indian Ocean as of now. Southern Indian Ocean, very much similar to the Atlantic and the portion of southern Pacific. It is only the north where you find this discrepancy, northern Indian Ocean. And that is because if you compare it with the northern Atlantic and northern Pacific for that matter, it is the Indian Ocean, northern Indian Ocean, where you have the greatest shift of the ITCZ. The ITCZ during the summer season comes somewhere or lies somewhere in this portion. The ITCZ lies somewhere across this area, isn't it? So here, as a result of that, what do you come across or what do you encounter? You will find that not in this situation. In this situation, or in this case, the ITCZ shifts somewhere here around the equator. So here, we observe that you have the movement of the winds which change direction between the different months. During the months of May, June, July, August, we have the movement of the winds in which direction? The movement of the winds is in this direction, the southwest monsoon. Isn't it? This is the movement of the wind that we have. So observe that the shape that the ocean currents will take will also be significantly clockwise. In the northern Indian Ocean, they will take a clockwise shape. Whereas during the months of from late September onwards, that is October, November, December, January, what is the direction of the winds? Direction of the winds is northeast to southwest. Northeast to southwest. As a result of that, you have the reversal of the currents, right? Aided by the wind again. Because it is in these months that you have the retreat of the monsoon, the withdrawal of the monsoon, and setting up of northeast monsoon winds, isn't it? So, northeast monsoon winds, along with the factor of the retreating monsoon, the wind direction will now be changing, completely reversed. That is not the case that you find in the other oceans. And here, because it is so closely surrounded by the landmass, this reversal of wind that will end up influencing the direction taken by the ocean currents as well. So it is only in the northern Indian Ocean where the ocean currents will completely reverse their direction. So here, the currents, ocean currents in northern Indian Ocean, revert their directions of flow with the reversal of winds. Okay? With the reversal of winds. So, as the winds will reverse between the various seasons, that is when you will encounter that even the ocean currents, they also reverse their directionality. That is why it will be clockwise in the case of the months of June, July, August. June to August. And then this will be reversed completely in the months of November to January. Okay. But in the southern Indian Ocean is very similar to that of southern Atlantic and southern Pacific in terms of being open and not surrounded by landmass or not being closed by the landmass. So in the southern Indian Ocean, you will follow you will observe the same pattern being followed. So here observe that you have the south equatorial current. That south equatorial current basically bifurcates or divides itself because of the obstruction provided by man. It is divided into the Aguilas and the Mozambique current that you have. So that is where the division happens. You have the Mozambique and the Aguilas warm current. Now then, you have the west wind drift, which is persistent and continuous across the entirety of the Southern Ocean. This west wind drift will deviate slightly to the left, and just like you had the formation of Peru current in the Pacific, Beniguela current in the Atlantic, similarly observe Beniguela current in the Atlantic, observe the Peru current in the Pacific. Similarly, you will have the Australia current, the West Australia current in the case of the Indian Ocean. So here that is why you have the West Australia current. And meanwhile, some amount of water from the region of the Pacific will enter into the Indian Ocean in the form of the Lewin current. Okay, so that completes the circulation in southern Indian Ocean, as compared to northern Indian Ocean. This is more consistent. This does not change with the seasons. But in the northern Indian Ocean, the direction of the currents, they reverse with the different seasons. Okay, counter equatorial current will be more or less the counter equatorial current, Ashwant, will be absent in many of the cases of from the month of June to August in this case, because most of the water here will be carried off due to the shape that you see, but still some counter equatorial current will be present throughout the year, Ashwant. It won't be completely absent. Some counter equatorial current will be present. Why currents from north do not enter the southern part? Because in southern part you have the own circulation which happens. The wind direction is very different from the northern and the southern part. If you observe the wind movement, what is the wind movement? Wind movement is like this. So if in the southern part you have the wind movement like this, do you think that the any ocean current from north will then move against the wind and then enter the southern ocean? Obviously not. Okay. So that is basically the factor that you observe in the case of Indian Ocean. And then now we come to the portion which has been in news for the past couple of years quite significantly, and which has been in relevance for the portion of geography as well, for the mains as well as prelims examination, but more mains oriented, little oriented towards prelims, and that is AMOC, or Atlantic Meridional Overturning Circulation, AMOC. Now, AMOC, what AMOC is, we will take a look into that. But before that, we address the larger picture or the larger scenario, that is global conveyor belt. I hope we understand the meaning of conveyor belt. I hope that is understood, right? So when we talk about conveyor belt, what is a conveyor belt? Generally, you observe it in the factory floors, in the malls, the airports, the railway stations that you go to. You would have observed the escalators, right? You would have observed that there is a kind of a, or the ones which you walk across as well. So there is a one which moves like this. It then turns and then the circulation happens, right? That is a kind of a conveyor belt that you come across. You would have come across this in flour mills, in various different aspects of when you move across an airport, railway station, a mall, you come across this conveyor belt. So that is a conveyor belt. So why is it referred to as a global conveyor belt? This is a part of a larger thermohaline circulation which happens in the oceans. And as a part of the larger thermohaline circulation, you would observe that water from the lower latitudes, they generally end up moving towards the higher latitudes. While significant portion of the water is circulated as an ocean current, some part of it sinks. It overturns, it sinks. And then after that, it starts reverting back. Okay, so it goes, it sinks, and some part of that starts reverting back. So that is the subsurface movement that we saw in the case of thermohaline circulation. And here, the water will come back here, under surface, subsurface. Okay, this is the subsurface movement. It might get warm or heated up by the time it reaches lower latitude. So there it might rise up. But otherwise, it will continue to move subsurface, and observe how in the subsurface, influenced by the mid-oceanic ridges and so on, the water ends up mixing. When it gets heated up, it rises, it moves back, it rises, it moves back. Whenever it gets heated up, it will rise closer to the surface. And you have the entire circulation like a conveyor belt. The water circulates itself. So this is what is referred to as the global conveyor belt. This is very important phenomena of the oceans in terms of regulation of temperature and the supply of nutrients in different parts of the oceans. Water from different oceans, they end up mixing with each other due to this factor of global conveyor belt. Now, this is not something which happens overnight. This is not something which happens, let's say, in the short term. This is something which takes a long time to happen. It takes close to around 1,000 years to complete one cycle, which means if a water from here has initiated the motion to come back to the same position again, it will encounter a time duration of close to around 1,000 years. So that is basically the part of global conveyor belt. Now, in that global conveyor belt, In the entirety of the portion, if you consider the portion of the Atlantic, so that Atlantic portion that you observe here, you will observe what happens in the region of the Atlantic. Water generally moves, it overturns or sinks in the higher latitude and gets back. There's a circulation. So that is the part of the global conveyor belt which is in existence in the Atlantic. That is the Atlantic meridional overturning circulation. Okay, overturning circulation. And this Atlantic meridional overturning circulation, very instrumental in influencing the climatic factors in the region of Atlantic. Very, very instrumental, very important. Now, this Atlantic meridional overturning circulation here, this particular portion that you see, the warmer water on top, I understand that we have studied that Gulf Stream moves from here, but this is a broader representation of the Gulf Stream. Gulf Stream is a major part of that AMOC. Okay, so AMOC significantly is constituted by the warmer waters of the Gulf Stream as well. Now, why this is in news? Why is it that it is so much relevant right now? Understand the basics here, very basics. So, for example, if I consider the water, if I consider here the low latitudes, let's assume lower latitudes, and here I consider high latitude. Okay, one by one principle I want you to apply. Very simple. Lower latitudes will get significantly heated up. They will expand. That expansion will initiate a motion, and that motion generally will be carried towards the higher latitudes. When they reach the higher latitudes, the water cools down sufficiently, becomes heavier, starts to sink, and you have overturning, and that circulation is the overturning circulation. But we know that climate change and global warming is a very prominent phenomena, is a major phenomena influencing us nowadays. Now, due to global warming, the temperature at higher latitudes, that temperature is increasing. Temperature is increasing due to global warming. Now, if the temperature at higher latitude is increasing, a water which has come from the lower latitude, this water. Now, if the higher latitude is also warm, will that water overturn? What do you think? If the higher latitude is also warmer, will that water be cold enough to sink? No. Water will not get so cold because the higher latitude itself is warmer. So, because of the higher latitudes becoming warmer, the water doesn't overturn as readily as it used to be. So, as a result of that, if the water is not overturning anymore, or the rate of overturn is, let's say, very slow, much, much slower than what it was earlier, what does that lead to? That means water will become stagnant. It will stay where it is for a longer duration. Now, when the water stays in the same region for a longer duration, it will receive greater amount of solar insolation. As the water keeps on moving, that heat keeps on getting dissipated. But if the water stays in the same region for a very long duration, the solar insolation will heat it tremendously, isn't it? Now, when that solar insolation heats the water tremendously, what atmospheric phenomena do we come across? What is it that we experience in that case? When the water stays in the same region and keeps on getting heated. Very good, Deepika. We experience, good, Hirubagar, cyclones and cyclonic formation. Now, cyclones in the region of Atlantic Ocean, they are referred to as, what is the name associated with the cyclones formed in the Atlantic Ocean? We call them hurricanes. That is why Atlantic has been experiencing a spate of hurricanes, very large amount of hurricanes. Okay. And that large hurricane, basically large frequency of hurricanes, that is influencing the countries around. So much so that for the past couple of years, the region of North America has experienced so frequent hurricanes that they have run out of the names also. They started naming them Alpha, Hurricane Beta, Hurricane Gamma, and so on. Now, this amok has got another connotation, another influence, why it is in news. So basically, again, understand another basic factor here. If I consider the water which is moving, let's suppose water which is moving. Now, apply the basics here. Water becomes colder when it goes to high latitude, right? Water becomes colder. Water becomes colder. Can it be inferred? Can this statement be rewritten as water loses heat? Water becomes colder and water loses heat. They are one and the same. When something loses heat, only then it becomes colder. So where will that heat go? When the water loses that heat, where will that heat go? That heat is supplied to the atmosphere in the higher latitudes. So when the water gets colder, it supplies that additional heat into the atmosphere. Water loses temperature, undergoes a kind of an overturning. But if that circulation, let's say, is inhibited, then that supply of heat in the atmosphere, that will also be disturbed ever so slightly, isn't it? Now, why is that heat in the atmosphere required? First of all, when we talk about the higher latitudes, the heat is not received to that extent as compared to the lower latitude, so the heat needs to be distributed. And when the atmosphere is warmer over a water body, what do you think will be the rate of evaporation? Rate of evaporation, will it be high or will it be low when the atmosphere is warmer? Rate of evaporation will be very high, right? Now, if the rate of evaporation is high, the probability of cloud formation will also be high, right? When you have greater probability of cloud formation, that will always bring greater amount of rainfall, isn't it? But now what is happening? The water is not cooling down at the same rate. Water is not becoming colder. So that means atmosphere is not gaining enough heat. That means evaporation is inhibited. If evaporation is inhibited, cloud formation will be hampered. If the cloud formation is hampered, you will come across lack of rainfall. This is the reason why the northern Atlantic has been experiencing a general lack of rainfall. And for the past 4 to 5 years, if you take an average, you will observe there are frequent heat waves which are influencing the region of Europe in general. So this is also a factor for the slowing down of amok, leading to a condition of drier regions of northern Atlantic and lesser rainfall in the region of northern Atlantic. Is that understood? Or is there a doubt which prevails? Good. So that is basically relevant for the portion of your current affairs, portion of your mains question in general. I will put that in writing so that you guys have a comparatively easier time. So slowing down of amok. Of amok. if you consider the Y of it, that is, higher latitudes are warming up water doesn't cool down enough, and as a consequence of that, no overturning. No overturning. Okay. Now, here the impacts. No overturning means water stays in the same region. When the water stays in the same region, you have greater solar insolation experienced over one particular area. As a result of that greater heating, and that greater heating will lead to frequent cyclones. This is again something that you don't find in your reference book. So please don't start searching the reference books for this. This is not something that you will find there. Okay. Then, other than that, the impact will be drier. So here, water, when cools down, or when water doesn't cool down. As a result of that, no heat supplied to atmosphere. As a result of that, lesser evaporation. That means lesser cloud formation, and that lesser cloud formation means dry conditions in West Europe and North Atlantic. Okay, so that is the very direct implication. You have the other impact also. The impact is that heat distribution and temperature distribution, heat distribution and nutrient circulation gets impacted. And when you have the nutrient circulation which gets impacted, it has got a large role to play in the biodiversity, especially the marine biodiversity in the polar area. They get influenced quite significantly. And that is why it has got a role to play in the living species as well. So that is basically the factor that you see with the case of AMOC, and that is what you see as a case of the global conveyor belt as well. So global conveyor belt is a system of ocean currents that transport water around the world, while wind primarily propels surface current, moves surface currents. Deep currents are driven by differences in water densities, that is a thermohaline circulation. Now, here, along this conveyor belt, heat and nutrients are moved around the world in a leisurely 1,000-year cycle. Now, when we talk about AMOC, the Gulf Stream is considered to be a part of the AMOC. As warm Gulf Stream or Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere, right? So, as it reaches, it cools and it releases the heat to the atmosphere. So as it cools, the water becomes more salty and dense and sinks to the bottom of the ocean. And that is a part of the conveyor belt in general. So if it does not cool down, it won't release the heat to the atmosphere. So when there won't be any heat in the atmosphere, no significant evaporation will be carried out. No evaporation will be carried out means what? You will have lesser cloud formation and you will have lesser amount of rainfall and drier conditions which will be prevalent for a longer period of time. Okay? Please understand, releasing heat to the atmosphere, understand one thing. If the atmosphere is heated, if you are finding it confusing in the case of why atmosphere needs to be heated up, if the atmosphere is heated up, will it have the ability to absorb more moisture or less moisture? All those who have doubt. As the atmosphere gets heated up, will it have the ability to absorb more moisture or less moisture? More moisture, isn't it? More moisture ability means greater evaporation. But if the atmosphere is colder, it won't be able to cause any evaporation. So, no evaporation means negligible rainfall, isn't it? Hence, dry conditions. Okay? As the same time, cyclone lead to heavy rain. So, see, please understand, the cyclones, they will not bring you meaningful rainfall to influence the temperature. Cyclones are very temporary phenomena. Cyclones are such a temporary phenomena, they will cause copious amount of rainfall in a short duration and then they will disappear. And that will bring about, after that, if it does not rain continuously, it will bring about oppressive heat conditions. Okay, so cyclones cannot be said to be as a solution to the heat waves. Temperature is high due to which evaporation is high. No, Lakshmi, temperature is not so very high that it can induce the impact of evaporation significantly, but it is high enough so that the water doesn't cool down sufficiently. So earlier, let's say the temperature was 0 degrees Celsius. Now it is around 3 to 4 or 4 to 5 degrees Celsius. Even that is enough in order to stop the water from overturning. Will it make ocean a dead zone in the later future? Yes. It has got the probability, and this is inducing a large scale migration of the marine species. Many of the marine species, they are finding it incredibly difficult to survive there because of the lack of nutrients. So that is why you will find that a lot of them are actually migrating. It means greater rainfall is broken by tropical cyclone than other, as in it means greater rainfall is broken by tropical cyclone. I'm unable to understand that. And does it impact the weather of the countries? Yes. Europe is experiencing drier conditions because of that. And the influence of the jet streams also come into play. And that is why you will find that Europe, for the past 4 to 5 years, Canada, for that matter, that is experiencing very dry conditions. You have wildfire incidents and events very frequent in these areas. Okay. Heating of atmosphere, Ashwant, leads to greater evaporation. Greater evaporation means more cloud formation and more continuous rainfall. Ilias, yes. You will have the impact in carbon sequestration as well. That will also be an impact. And it will have any impact in Atlantic Ocean current. The currents in general slow down. Uh, why high temperature generated in higher latitudes? Because of global warming. Wave 3 amok can cause pollution as well. If we throw a bottle in Indian Ocean after years, it will be present in the Atlantic. Well, the global conveyor belt ensures that the entire circulation does happen. And that is why the pollutants that you throw here, they might be found in the region of the Pacific Ocean as well. In India, you don't have a direct impact on AMOC, but last year, there has been a research paper which has been submitted in India. And that is basically, that claims that you have the influence on advancing monsoon as well. But till now, we don't have a clear-cut evidence on that. So let's see how it comes up. Because the atmosphere near the tropics absorb more moisture, that is why they cause rainfall. In the tropics, the rainfall is not caused significantly because you have a sinking air column that does not allow. But in the region where you have the subpolar area, you have a rising air column. If there also you don't have rainfall, then that is a cause of concern. Okay. Yes, yesterday also there was a wildfire. How many of us we have no clue what is a conveyor belt? Still, we have no clue what this conveyor belt is. We have worn belts in our pants, but what is this conveyor belt? Any of us who has no clue? Okay, fair enough. Okay. A conveyor belt is basically a belt which circulates and comes back to the original position. That is what is referred to as a conveyor belt. In mills, in let alone mills, you would have come across the shopping malls. You would have gone to shopping malls, or you would have seen markets, you would have seen railway stations, anything. Now, there you come across escalators. Escalators, what do? You stand in a position, escalators will carry you to the top, and then that belt comes back and again it carries you to the top, isn't it? Now, what is that? That is a conveyor belt, right? Yes, correctly pointed out. When you go to the malls, your baggage scan is done, or you keep the bag on a belt and it moves through a machine. That is a conveyor belt. So conveyor belt basically is that rotating belt or the moving belt which comes back to its original position, as simple as that. Now, when we say a global conveyor belt, across the entirety of the globe, the oceans, the water experiences a similar motion where the ocean currents, as they move, along with that, there is a thermohaline circulation which is initiated, due to which water simply cools down, sinks, and then flows back. Now, this thermohaline circulation is responsible for distribution of heat and nutrients over a larger area. Now, when we talk about the Atlantic Ocean, in the region of the Atlantic, you have the overturning also. That is the Atlantic meridional overturning circulation. It is a part of the global conveyor belt. And that Atlantic meridional overturning circulation, or AMOC, that is slowing down, influencing the climatic conditions in that area. And that is why a cause of concern. Now, ocean conveyor belt describes the interaction of surface currents with deep, slow-moving underwater currents. And here, these mix ocean water, salts, and even organisms on a larger scale. Okay? Is that understood? Or do we have any doubts which exist? During AMOC, is it affect the other flows like tides, waves? Tides and waves are not impacted by this. Tides and waves are very, very different. Tides and waves are a very different concept, my dear friend. It is a very localized phenomena. Ocean currents, thermohaline circulation, that is something which happens across the globe on a global scale. Okay. Now we come to the impacts, or yes, Swapnil, it is almost similar. Now we come to the impacts or the effects of ocean current. What is the effect of ocean current in general? Shalu, that is what I have summarized, isn't it? What kind of summarization do you need? Is that summarization sufficient, or what summarization are we talking about here? Do you want me to write the definition of global conveyor belt and the AMOC? That is where you have the write up. What do we mean by summarization here? Kindly clarify. Any relation between stagnant heating and oxygen decline in ocean waters? So there is a long-term relation of that. You will study it in when you come across ocean acidification, climate change, etc. That is when you will come across. So I hope this summarization is sufficient, guys. I hope you will be able to revise with this, that why the slowing down is happening, why no overturning is happening, what is the impact of that, why frequent cyclones will be created, why you will have drier conditions in the northern Atlantic, and also how the biodiversity will be impacted. I hope that is clear. If any doubts prevail, feel free to ask. Okay? Now, after this, we come across the effects of ocean current. What are the impacts of ocean current and the effects of ocean current in the region? Wildfire, Vivek, is basically, what is a wildfire? Something that you don't create on your own, and something that spreads in a kind of an uncontrolled fashion. That is wildfire. So that can be when you have very dry conditions prevalent for a very long period of time. So the temperature rises significantly, the conditions become very, very dry. And as a result of that, what happens is that you have even a stray incident of lightning will give rise to a fire which will spread viciously. That is a wildfire. Why cooling down not taking place? Please tell. Okay. Cooling down doesn't take place. Observe here. Temperature is increasing because of global warming. The temperature in the higher latitudes is increasing because of global warming. So as the temperature in the higher latitudes is increasing, the water won't be sinking anymore. The water, why does the water sink in a thermohaline circulation? Think about the basics. That is what I told you. Attack the basics. Why does the water sink in the higher latitudes? Because the water gets very cold, and that is when it becomes heavier, it starts sinking. If it doesn't become very cold, then it will not sink. Why won't it become very cold? Because the temperature is increasing because of global warming. And that is why water stays in the same region for a longer duration. So higher latitudes are warming up. Why are the higher latitudes warming up? Is this because some god suddenly became unhappy and now the higher latitudes will have to face the consequences of it? Absolutely not. Here, this is initiated by global warming. Global warming. And that is why it is slowing down. And that is why the water doesn't cool down enough. When the water doesn't cool down enough, no overturning. And because of that, you have the consequences. Is that understood now? Does AMOC have impact on more induced global warming? Yes, it will have a long-term impact, Ashwant. So now can we proceed? Good. So now we come to the effects of ocean current, the impact of ocean current in general. So when we talk about the effects, first of all, wherever you have the presence of warm and ocean current which will end up interacting, that will always create an ideal fishing zone. Okay. So wherever you have the condition of warm and cold ocean current meeting in those areas, immediately the oxygen supply start, the dissolved oxygen quantity starts increasing. So as the dissolved oxygen content starts to increase, as a consequence of that, what happens? You have greater proportion of phytoplanktons, greater proportion of fishes. So very ideal. fishing ground. So majority of the fishing grounds in the world exist in these regions. Effects of ocean current, if you observe here, it also helps in navigation. Navigation is movement of ships and vessels from one region to another. So there also you have a significant help which is aided by the ocean current. Now, other than that, whenever you have warm and cold ocean current meeting, there you will also come across the creation of a sea fog, because the warm air will also meet with the cold air. So, meeting of warm and cold ocean currents creates meeting of warm and cold air, and this creates fog, dense fog, and that is a nightmare for navigation. There is another factor, that is wherever you have the presence of cold currents. Now, in those areas, you will find that you will experience the presence of deserts. And that is why across the western margin of the continents where you have these cold currents, you will always come across the formation or the creation of deserts. Why is it so? So here again, apply your logic, very simple logic here. So if let's suppose this is the land area, here next to the land area, let's suppose you have the water. Okay, you have the water. Now that water, if it is very cold, cold current means it is much colder than the surrounding. So if it is very cold, it what will it have, or its influence will be felt in the air also. So the air will also become colder, isn't it? Now when the air becomes colder, what condition will it lead to? It will lead to, can we say that what conditions does it lead to when you have the base as cold and above you have warmer air? What condition does it lead to? It will lead to a condition of inversion. Inversion means lack of rains. Lack of rains means formation of deserts. Formation of deserts. Okay, that is why you will find, take the case of South America, western part of South America, you have the Peru current which is present. You have the Atacama Desert, which is created as a consequence. Even in some parts across the eastern part, you have the cold Falkland current. That cold Falkland current creates the Patagonia Desert in that area. Then observe in the western part of Africa, you have the cold Beniguela current. That creates the cold Namib Desert in that area. Then observe in the western part of Australia, you have the West Australian current. That creates the Victorian Desert, warm Victorian Desert in the region of Australia. Right? You have the cold California current in the region of West North America, and that creates the Mojave Desert in North America. So that is why you have the formation of deserts in the western part, typically the western part of the continents in general. Then we come across what is referred to as the Sargasso Sea. Okay. Madhur, I think there will be 2 extra classes because of our speed. See, as long as you guys are ready and you guys are able to understand, I don't mind taking the extra session, but we will need an extra session. We already have wasted 1 hour due to some technical defect. And yes, we are going slow. But please understand, look at the larger picture, my dear friend. 1 year down the line, if the concept of geography is clear, 1 year down the line, you will never even remember how many classes did you attend. So look at the larger picture. As long as you are able to understand, no issues. Then Patagonia Desert is formed due to rain shadow region. Yes, that is correct. It is on the rain shadow area of the Andes, but the cold Falkland current in some part doesn't help either, right? And then after that, deserts are hot, so low pressure, or not all the deserts are hot. Uh, uh, Samarjeet, not all the deserts are hot. We have many cold deserts also. Atacama Desert, Namib Desert, Patagonia Desert, these are cold deserts, right? So you have hot and cold deserts, both are in existence. Okay. And how to distinguish which current will make hot or cold desert? See, it is the hot and the cold desert is not initiated by the current or not influenced. Desert will be influenced by the current. Whether it is hot or cold will be influenced by the location, the climatic aspect, and the atmospheric condition. Okay, I hope that is clear, right? The extra session, if it will happen, it will happen. I'll try to get a session sneaked in next Saturday. Next Saturday in the morning time, I will get the extra session for mapping, maybe. Okay. So now we come to the portion of, yes, Mojave Desert is in California, and its spelling is not Mohavi. Its spelling is Mojave Desert is this. The spelling is this. Okay, this is referred to as Mojave. Now, after that, we come to the Sargasso Sea. What is this Sargasso Sea? First of all, you would have heard about the frequent mention of seas and oceans, seas and oceans. So, what is the difference? Ocean is a very large water body, right? Very, very large water body. And generally, the margins of the ocean, which have a surrounding by the land, which are surrounded by land in general, that is what is referred to as a sea. So sea is a small subcomponent in a way, or a subset in a way, of a larger ocean in general. So when we talk about Sargasso Sea, so this is a region in the area of Central Atlantic, North Central Atlantic. And here you have a mixture of different conditions taking place, which creates a very unique scenario. So for the first time, this was basically discovered by the Portuguese sailors. And the Portuguese sailors, when they would travel across the Atlantic, as I already told you, they would come across this vast expanse of bluish algal weeds which are floating in the ocean. Now, this is how the weeds look like in cross section. And these weeds that you see, basically the algal species, they are very good for biodiversity of that region. They will be able to support a lot of biodiversity. But here, overall, imagine for a ship which is traveling in this area, it will be a nightmare because the ships have propellers. And in those propeller blades, if these get stuck, then you won't have any motion at all. The ship will be dead still in the water. So that is why this particular expanse, it was named after the seaweeds that you find. And seaweeds in Portuguese, that is referred to as sargassum. And from that, you have the name Sargasso Sea. Now here, why is it that you have the growth of seaweeds, or what is this Sargasso Sea? So in the region of Atlantic, you have the North Equatorial Current in this area, and that North Equatorial Current, basically aided by the shape of the coastline, the Coriolis force, that will bend here, right? Now, as the water here is moving, it will initiate the movement here also. Some water will move here also on the sides of it. It will drag some water. that will drag a little water on the sides also, right? But slowly and steadily, the impact of that drag reduces as you go in the central portion, right? Now, the same is the case with the Gulf Stream. Same is the case with North Atlantic Drift also. So while the currents are moving, as you come to the central portion, there won't be that much amount of motion due to the currents. So as a result of that, you will find that the central portion is largely left undisturbed. Okay, because the ocean currents won't have an influence there. And on top of that, this Sargasso Sea lies very much in a region of high pressure zone, the subtropical high pressure zone in general. Now, high pressure zone, a subtropical high pressure zone means what? Lack of wind movement, a sufficient lack of wind movement. So, no motion of water in that region. So, that is where you have, excuse me. So, that is where you have undisturbed waters surrounded by what? Surrounded by north equatorial current to the south, Gulf Stream in the west, North Atlantic Drift in the north, and then you have Canary Current in the east. So here what do you observe? You observe that the water is almost still. And as the water is almost still here, no movement is experienced. As a consequence of that, what happens? Seaweed starts growing. And that entire stretch is filled with the Portuguese term sargassum, and hence the name Sargasso Sea. So how is that Sargasso Sea created? First of all, you have the movement of the ocean currents. All around, as the ocean current moves, the central portion remains undisturbed because the ocean current moves to the sides. So the central portion, a large area, will remain undisturbed. And undisturbed means there won't be much mixing of water from here to here or here to here. Water will not mix with the surrounding regions. So as the water is not mixing with the surrounding regions, the water will lie undisturbed in a particular area. And that is what is referred to as Sargasso Sea. Is that understood? Lakshmi, now that I have repeated, is that understood now? Or is that still not understood? This region of Bermuda Triangle also exists in that area, yes. Any doubts that we have till now? Please let me know. Sargasso Sea doesn't move, no. Not part of AMOC, no. Okay? So that is basic. What will you do with the story? So if you have understood the concept of Sargasso Sea, fair enough. Okay? That is what is asked in the exam. In examination, nobody asks you what is the story associated. The story that I tell you is largely to help you associate with it. Sargassum is the name of the seaweed, which is basically, or the name associated with the seaweed, which was basically discovered by the Portuguese explorers as they were moving across the Atlantic. So, okay. Why middle portion does not move? Because that is that is a region where you also have the subtropical high pressure belt, and subtropical high pressure belt basically means lack of winds, basically, which means no movement. Okay, right? Why water is being undisturbed? Because all around it, as the water is moving, the central portion is not carried away. So if you have an ocean current, think about it. That ocean current, will it drag water here also? Absolutely not. So that ocean current will be dragging water here, here, and here. That at max, it won't be able to drag the water in the central Atlantic. So that is why you have the central portion which is undisturbed. Now, after this, we come to the portion of coral reefs. Now, when we talk about coral reefs, this is going to be relevant for your portion of environment and ecology significantly. Here, we are going to cover the geographical perspective of it. We are going to cover the types of reefs in general. Here, we are going to talk about the types of reefs. Okay, what are the various different types of reefs? So basically, you have the types, that is fringing reef, barrier reef, atoll. These are basically the types of reefs in general. Now, here, what are these coral reefs and what are corals? Corals are basically individual corals. These are referred to as the coral polyps, and these are marine animals which live on the bottom of the sea floor, or basically in the shallower waters is where you will find them. Now, these corals in general, you'll find that there you have a symbiotic relationship, a mutualistic relationship. And these corals, they have a mutual relationship with the algal species, that is the zooxanthellae. And that algal species, that is what is responsible for providing the unique coloration pattern to all the corals that you observe. Now, these corals have the unique ability to synthesize calcium and carbonate from the surrounding water, and they build a calcium carbonate exoskeleton around them. Now, that calcium carbonate exoskeleton that they build, that is basically connected, and that brings about what is a reef. Now, these corals, they are also referred to as the reefs. Coral reefs are also referred to as the rainforest of the ocean ecosystem. And why is that? Because they have a symbiotic or a mutualistic relationship with the zooxanthellae, they carry out or they provide enough amount of oxygen into the water. So that is why, just like in the case of the rainforest, the corals also end up providing a lot of oxygen into the water. And they also provide a shelter to large number of species, large number of biodiversity. And hence, it is very, very important for the ocean ecosystem. So let us understand the corals. So coral reef is an underwater ecosystem characterized by reef building corals, and it is built by the colonies of coral polyps held together by calcium carbonate, which is synthesized by the corals themselves. Now, most coral reefs are built from stony corals whose polyps, they cluster in groups. Okay. Now, the largest coral reef that you come across is the Great Barrier Reef in the northeastern part of Australia. That is very large. Now, coral reefs are of various different types. You have the cold water corals also, warm water corals also. But majority of the corals that we have discovered till now, they are warm water corals. So they will have certain conditions for growth and certain requirement in general. Cold water corals, they can be found in areas across even Norway, at the ocean bottom, and their functionality is going to be very, very different in general. Okay, so here we are going to talk about the warm water corals in general, ever so briefly. So here, when we talk about these coral reefs, this is what a coral polyp looks like. This is a coral polyp. Now, this coral polyp has got a very simple body morphology. You will find that it has got an orifice for the mouth, and that is where it starts ingesting food. And here is the digestive tract that you come across. Here you will have the tentacles. Now, these tentacles are basically for trapping food and taking inwards, because the corals, they are fixed to the ground. Okay, they are not moving. So, excuse me. So the corals are basically fixed to the ground. They don't end up moving. So they need food. Where do they get that food from? So they basically assimilate food from the surrounding areas, any floating objects from the surrounding, floating particles, etc., and they take in. But obviously, the quantity of food is never going to be sufficient in that case. So that is why they come across a mutually beneficial relationship, mutualistic relation with zooxanthellae. Zooxanthellae is a species of an algae. And this zooxanthellae has the ability to manufacture its own food by carrying out photosynthesis. Carries out photosynthesis. So has got the ability to manufacture own food and also produces oxygen. And this food, by the way, is required for the existence and the survivability of the corals in general. That food which is produced is very much required. And here, provide oxygen. So why it is a mutually beneficial relationship in general is that corals, they provide them with a platform and supply of calcium carbonate. And zooxanthellae in return will make food that will be provided to the corals. So both of them benefit in this. So that is why zooxanthellae is very essential. So when we talk about the warm water corals, here, this warm water coral in general, you will find the conditions required for the growth. Availability of sunshine, because the corals need, the zooxanthellae needs to carry out photosynthesis. Availability of sunshine. Then after that, clear saline water. They cannot grow in fresh water, cannot grow in muddy water. Okay. Then constant or consistent temperature. Around 24 to 26 degrees Celsius. Okay. So that is something which you find as a necessary factor. So wherever you have muddy water, etc., the corals won't be found. That is why in Sundarbans Delta, you don't have the corals because you have a lot of muddy water there. So this is the condition required for the corals. And the corals, when they synthesize the calcium carbonate, they will build that calcium carbonate skeleton, and the next generation will keep on growing on top of them. Once the corals will die, the next generation will utilize the same calcium carbonate exoskeleton to grow on top. So that is how, if you consider, let's suppose the sea surface, that is how you will observe that the corals, they start to grow. Okay. You will observe that one generation will leave behind a set of calcium carbonate. That is when eventually they will end up growing layer upon layer. Right. Now they will keep on growing, and it takes hundreds of years, in general, many hundred years, to have the next generation come over and next generation come over. As soon as they come above water, as soon as they come above water, here, that is when they will die, because these are marine species. These are not terrestrial species. So as soon as they come above water, they will die. Now, as they die, they will leave behind the stony calcium carbonate exoskeleton, the whitish exoskeleton. Slowly and steadily, that will disintegrate to form whitish sands. And over a period of time, this forms a kind of an island in between the sea or an ocean. And you will find lot of various different birds, etc. They will start taking shelter here. The migratory birds who carry seeds and food, they will take shelter here. Inadvertently, they will drop something or some seed, etc. And that is when you will start observing the growth of plants in this area. You will start observing the growth of plants in general. Right? And slowly and steadily, it gets converted into a coral island. So that is how, in many of the cases, coral islands are created. For example, take the case of Lakshadweep. Lakshadweep is an ideal example of a coral island. Example, Lakshadweep. Example, Maldives. Example, few islands in the Andaman region also. So all these are created because of the events of corals and the formation of corals. Hence, you have the coral islands. So that is the formation of coral islands, and these are the regions where you will find the warm water corals, the spread of warm water corals in general. Here you will find an increased density of the corals in this area, because this is where you have so many thousands of islands. The water is not very deep, and that allows the penetration of sunlight, and that allows for the growth as well. So this is basically where you will find predominant coral population. Coral population. This is also where it is referred to as a coral triangle. Coral triangle. That is Indonesia, Philippines, and Australia. In this stretch, you will find a lot of corals to be present in general. So that is what is also referred to as a coral triangle. Now, these corals, they also undergo what is referred to as bleaching or coral bleaching. Now, this coral bleaching is basically when you will find that the portion of the corals here, which are inhabited by the zooxanthellae, that portion of the corals here, the zooxanthellae dies off. Its productivity reduces, it dies off. And when the zooxanthellae dies, means the corals, they are left with their stony white exoskeleton itself, and they don't have enough food, and the corals also die. And that influences the marine ecosystem for a long period of time. So that coral bleaching happens because of sudden change in temperature, because of pollution, and other factors that can initiate the coral bleaching in an area. Okay. Now, here, let us come to the geographical aspect. What are the types of coral reefs? So, depending upon where the corals are to be found, they are classified, or they are basically known to have different reef-like structures. So, for example, if you have, let's say, a mountainous area or an island region, for example. Now, across the coastline, the corals will develop because that is where the shallow waters are present. So that is where the corals will develop. This is referred to as the fringing reef. Fringing reef because it is on the fringes, on the sides. So that is what is referred to as a fringing reef. Okay. This is a fringing reef. Now, sometimes, how is it that islands are created? Due to volcanic eruption, the endogenic forces we have studied in geomorphology, that endogenic forces, they will raise a particular landmass. They also have the ability where the landmass starts sinking. Both of the events can happen. The landmass gets raised, the landmass starts sinking as well. So when we talk about these endogenic forces, the landmass that starts sinking as well sometimes. As the landmass, let's say, sinks, the corals, they are left where they are and water enters in between. So these corals, they form a kind of a barrier-like feature. And that is when they are referred to as the barrier reefs. You have a water coming in between, a shallow water body which comes in between. And let's suppose that entire landmass has sunk. It leaves nothing behind and only the corals are left over. So here the water will be shallow and here the water will be very deep. So these are referred to as atolls. So that is what we have as fringing reef, barrier reef, and atolls in general. So fringing reefs, they are formed along the coast of the continents or islands, and their surface is connected with the coast. Here, observe, this is the fringing reef. Here they will grow on the sides of the coastline. They will grow on the sides of the coastline. Right? And then that is what is the fringing reef. That is what is the fringing reef. Okay, it grows on the fringes, it grows on the sides. Now, if the central landmass starts to sink, observe that you have some shallow water body which is created because the water comes inwards as the corals, they remain in their own place, and that forms a kind of a barrier reef. Okay, example, the Great Barrier Reef off the coast of Australia. And when this completely sinks, you are left with that whitish portion in between. And this is the portion where the coral would have sunk. And observe the color of the water here, absolutely dark, blackish almost. That tells you how deep the water will be in this portion. And here you observe the water is almost whitish. Why? Is it because the water is very clean here? No, it is because this is dominated by calcium carbonate in general. You have a lot of calcium carbonate, which is uh, synthesized by the corals and they make the exoskeleton. That is why across the coral islands, you will come across this kind of turquoise blue water. It is not that the water is very clean. Water is same as you find in majority of the oceans. But there you will find that because there is calcium carbonate and which is whitish in color, there is a lot of reflection which happens. And that is why you will find it is bluish in characteristic. So these are what are referred to as atolls. So atolls basically are the common type of coral reefs, roughly circular or a horseshoe, where the central portion has completely sunk. So a fringing reef can get converted into a kind of an atoll over a period of time. So this is the entire cycle of it. It is initiated by the formation of, let's say, a volcanic landmass, for example. Now, once the volcano doesn't go on anymore or is not active anymore, after some time, let's say there is a kind of a sink and a subsidence. When there is a sink or subsidence, observe first of all the fringing reefs develop. Then, as there is more sink around the region of the reefs, water also comes in. That forms what is referred to as a barrier reef. And after that, when there is a complete sink which happens, you have nothing but atoll, which is left behind. Okay, so that is the formation of atoll. Okay, is the audio and video clear? Okay, good. In barriers and atolls, why don't they sink if there is no support? Utkarsh, in the case of barriers and atolls, so here, by the time that the fringing reefs develop, they will develop their own base significantly. Okay, built up of calcium carbonate. And then if the central portion sinks, that is why they will be able to hold their place, because the sink also will not happen suddenly. The sink is also very slow, maybe 1 centimeter sink in one or in, let's say, in 100 years or 200 years, 1 centimeter has sunk, or 2 centimeter has sunk in 50 years. So that is enough time for the corals to build the support meanwhile. Okay, Lakshmi, but in this case, they grow outside the sea. Then how do they survive? They don't grow outside the sea. This portion that you see, which is protruding from the sea, that is dead coral. That is where you'll find the formation of islands in general. This is where you'll find habitations to exist. Coral islands are created here. Okay. Are barrier reefs and atolls floating over water? Not always. Atolls, you will find few of the islands which are present, but they are not floating. They are connected to the mass underneath as well. Okay. Mostly we see other country islands of bluish color of water. So that bluish water, for example, you will find that, let's say, a few of your friends visited Maldives. They posted a picture of very nice bluish water. It is coral reefs. You will find any of your friends when they visit the Pacific region. There also, when they will post the beautiful pictures on the social media, you will find a turquoise blue water. Now, that also, you'll find that in the coastal area, in many of the fringing reefs, you have the calcium carbonate which is present. And understand, if the base is white, the light reflected will be significant. And that is when the color starts to appear in a turquoise blue, and water appears very different in that case. Okay. Maldives is an atoll, yes. El Nino effects also harm it, because El Nino will increase the temperature in that particular area. So it will lead to the destruction or the kind of uh, coral bleaching. Shallow if sinking, it means where magma sink inside the earth. No, the general diastrophism that we had studied, rising up and sinking down of the landmass. Does the coral reef form around a volcano? How is a new landmass created? A new island, how is it created? As a result of a volcanic eruption, majority of the cases. So that is when the volcanoes, they are not existent anymore, the corals will start to grow. Okay. And why are they more adapted to warm water? They are also adapted to the colder water. Some of the corals, if you think about, that is how the body morphology is designed and shaped. Have you ever thought about it, why elephants are to be found here only? Why elephants are not to be found in the polar areas? That is how the body is designed. That is how the body is adapted. The human body, why is it not designed to live in the in the region of Antarctica? That is how the body is designed. Atoll also will sink after a few time. Not always. Not always. The rising sea level will end up creating that scenario, but not always. Ashwan, the fishing ground will be present, but it will not be very, very, very significant in the region of Sargasso Sea. The region where you have the corals, these also are very rich in terms of fisheries. They will support a lot of fish population. Can atolls form fringing reef again? No, they will not. Okay. Yes, Pooja. Slowly and steadily, it develops into a kind of a coral island. Is coral found on oceanic uh, bed? No. Corals on, yes, you have certain corals. For example, you have the category of black corals. They can be found on the oceanic bed, the cold water corals. So they don't enter into a mutualistic relationship with the zooxanthellae. It can form on the continental coast also. Why coral bleaching happens, Samarjit? Because if the, let's say, temperature suddenly changes, if, let's say, the water becomes very polluted, so all these will lead to coral bleaching. Ilyas, we will start Indian geography from tomorrow. That ends the portion of oceanography. And now from tomorrow, we will initiate the discussion about Indian geography. We'll start with the basic physiography. So the importance of corals is extended into the portion of fishing and also tourism purposes. Very relevant for the tourism as well, supports a large section of population. And also these corals, they provide a kind of a barrier where the waves will break. The waves will not end up causing much damage to the coast if you have the corals in that region, because the waves will break much before that and you will have a calmer water. Okay. Yes, Kavya, that is correct. Coral reefs in India are mainly restricted to Andaman Nicobar Gulf. Yes. In Coral Island, the sand seems to be whitish in color due to the calcium carbonate. Absolutely, yes. Can other corals can start to live on atolls, not above the seawater, below the seawater? Yes. Okay. So that is where I'll give you a practice question also based upon the PYQ. Kindly try to write the answer for this. So this is actually a previous year question. Are the factors which influence the ocean currents? Discuss the impact of ocean currents across a region. Now here, even though if it is not written, elaborate with examples, you have to write examples for this. I'll make it easier. I'll give it for 10 marks, 150 words. Yes, Pravasini. Zooxanthellae responsible for colors of corals. Can we create corals artificially? Yes. Chinmay, you have the bio-rock technology which is available. All of that you will study in the portion of environment, whenever that environment is done. Without zooxanthellae, corals would die. Yes, they don't have enough supply of food. They do catch some food, but that is not enough. With bleaching, the corals will die. Yes, Lakshmi. Arnab, if I take geography optional from Byju's, will you take classes or will I? See, in the case of geography optional also, we have a detailed lecture set which is provided, and this is that session is covered by other experienced faculties. That is not something which is covered by me, but nonetheless, if you do take up those classes course, uh, you are free to contact me in case of any issues. I'll help you out as much as possible, but there you don't have my lectures, no. And Jyoti, why are you not answering my questions? A few minutes back, I had the same allegation put forward by Lakshmi. Why are you not answering my questions? So maybe the questions you are asking are so difficult that I'm unable to understand. That is why I'm ignoring those questions. I can't think of any other excuse. What is your question? Please let me know. What is your question that it is that I have been ignoring? And I had another student who had complained this, that you are ignoring my questions. So I think, yeah, I'm doing this for everyone. So at least there is no discrimination here. What is the question that is there? When will we give answer to this question? Is that the question, that when will we give answer to this question? As soon as possible. Try writing it today, send it. Is that the question that I was not answering? Or was there something else? Okay. Vivek, my doubt. Okay, what is your doubt? How coral islands are formed. So slowly and steadily, as the corals they grow, they synthesize the calcium carbonate, they build an exoskeleton. As they end up growing, eventually, as soon as they come above water, that is when they will die, and you are left with a stony calcium carbonate structure which weathers, erodes to form the whitish sand that you observe. Now that is a kind of an island which is formed in the ocean or the sea. Slowly the birds will come in, everybody will come in, they will start taking shelter, and vegetation also then comes in. Okay. If atoll atoll basically is when you have the central portion completely sinks, leaving behind the corals in existence. That is atoll. Siddharth, water evaporates by more heating. Then why, in case of amok, warm water does not evaporate? That is what I was telling you, Siddharth, that warm water, and I had replied this as an other question. So warm water does not mean water there is at a temperature of, let's say, 25, 30 degrees Celsius. Water already is at a temperature of somewhere around 5 degrees, 7 degrees Celsius. So that is not enough to initiate a lot of evaporation. So in that case, or also understand, evaporation that happens also depends upon the saturation of air. So warmer the air, greater is the carrying capacity of the air. We have studied that under humidity and precipitation. So if you have air which is cold, it will not be able to hold any moisture, right? It will have, let's say, 5 grams moisture, 5 grams of rainfall will be done and dusted. So that is not sufficient to bring rainfall in Europe. That will be sufficient to bring rainfall in isolated areas here and there. So if the atmosphere is warmer, it will have much more evaporation, greater amount of water vapor it will carry, more rainfall it will drop. Okay. Yes, Madhur, the session is done. Would stagnant water of Sargasso Sea lead to lack of oxygen in that area? No, the weeds grow. The seaweeds, the algal population grows. They carry out photosynthesis and they produce oxygen. Will atoll convert? Atolls are made up of many islands, Pooja. Atolls eventually end up forming many islands. The question page. Okay, Chinmay. How will send the answer to the question? Write the answer, send it to us at IS Live or Target IS, anywhere you can send. You guys have my mail ID, isn't it? Mail ID you were asking. My mail ID. And again, while providing my mail ID, let me clarify. It is not as if that immediately you will send a mail and immediately within few minutes I'll be able to reply. Right? So give me a couple of days time. I will reply in a couple of days. If there is no reply in a couple of days, be kind enough to send over a gentle reminder. Okay. And Rahul, there is a lack of information on app as well as about the optionals as to who will. You can contact the mentors, Rahul. In that case, the mentors will let you know. If corals found at the oceanic coral, then how will they survive if no sunlight? If coral found at the oceanic coral, Shalu, please try to make sense of the question that you have framed. And Vejshri, why are corals black in some places? So that is a different genus of corals in general. That is a different subspecies of corals that you have. That is referred to as black corals. It is they don't enter into symbiotic relationship with zooxanthellae. Sometimes you have the chemotrophs, otherwise they are able to synthesize the calcium carbonate and trap their own food. Okay, if corals found at ocean bed, then how will they survive if no sunlight available? So they have a different body morphology. They have a different methodology of survivability. They have basically got a sometimes it has been found, not many have been discovered till now, but sometimes it has been found that they don't enter into a symbiotic relationship. They have the tentacles and they are filter feeders in general. That is, anything which is floating in the ocean, the particles, the salts, the ions, etc., they trap that and they keep that. So you have certain worms, etc., which also help them, but then they are not dependent on zooxanthellae. Zooxanthellae is the one which requires the availability of sunlight. Yes, Sejal, the next generation will grow. Deepika, you have the rotation of the earth as along with the westerlies which are responsible for that. Why was there still water in Sargasso Sea? Yes, Vivek, there is still water because the ocean currents move all around it. In the central portion, the water is left undisturbed, and in the central portion, you have the sinking of air also due to the high pressure. Are ocean currents affected during spring tides? Not much. Okay. Yes, Preeti, you can. Yes, Anshu, Byju's does provide that. We have a host of optional subjects on offer. You can take a look at it. So for these, always feel free to get in touch with the mentors. No, Tushar. The zooxanthellae mostly you'll find them to be living with the corals. Okay, I hope that is clear. So that covers our journey for physical geography. With the help of the physical geography, we have covered the entirety of the portion of the globe. So if tomorrow someone asks you, where is Atacama Desert? Where is Gobi Desert? Where is it that you have Namib Desert? Where is it that you have the Kalahari Desert? I am expecting this, that not only will you be able to provide the location, you will be able to provide the reasoning of that as well. I hope that you will be able to provide the reason that why you have significant amount of islands in the region of southeastern part of Asia, and why you have so many coral population living in that area. I hope now you will be able to provide the reason why northeastern part of North America is a very rich fishing ground. And I hope you will be able to provide the reason why the Indian Ocean experiences a reversal of wind direction. So we have covered the various facets of the physical and the world geography, sufficient for your mains examination. That is something you should keep in mind. Try to revise it as many times as possible. Tomorrow, we initiate the journey for Indian geography, and that is the entirety of the purpose why UPSC wants you to study all this in order to understand India better. So, tomorrow, we initiate the discussion for Indian geography. Join us tomorrow, and I'll tell you a new approach to study the physiography of the country, other than what is mentioned in the books and other than what you generally come across in the other supply or the general sources. Tomorrow, we shall be talking about the formation of the Indian landmass. While I understand we have already talked about the formation of the Himalayas, tomorrow, we shall be discussing about how is it that the northern plains come into existence? How is it that the Peninsula Plateau was formed? Why is it that the rivers Ganga, Brahmaputra, etc., they drain through the region of Bangladesh and West Bengal into Bay of Bengal? Why is it that across the western coastline we have a wide coast or wide continental shelf and still it is ideal for fishing? Why is it that the eastern coast is not significantly ideal for building ports and harbors? All that we'll discuss tomorrow. Till that point of time, take care of yourself. Goodbye. Thank you.